A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. We shall be starting in a couple of moments. Zeba, yardangs get their shape based upon when you have the base rocks, when they are exposed to wind. So that is when the wind tends to erode the base rocks. And there also base rocks will have different type of composition. It might have a structure where you have a soft rock at the base of that rock and a hard rock at the top. So that is why generally when you will find the presence of the yardangs, you will find that the top is almost undisturbed, whereas it is the bottom portion of the base rock which keeps on getting eroded. So as the wind strikes these base rocks carrying all the smaller particles, it tends to lead to a small fragmentation thereby. Okay. So hello, a very warm good morning to all of you and welcome to Baiju's Exam Prep IES. Welcome to the session for climatology, where yesterday we had initiated our discussion about climatology and we had started the discussion with the first and the basic module of climatology, that is about atmosphere and temperature. Now, when we talk about the portion of atmosphere and temperature, there we had introduced ourselves to the process of evolution of atmosphere, where we actually observe that the atmosphere around us has also evolved just like the planet on which we are living. Where, in the case of a primordial atmosphere, you had the presence of only hydrogen and helium. And thereafter, you had the introduction of newer gases during the phase of degasification, where you had hundreds and thousands of volcanic eruptions rocking the entirety of the planet's surface. So, during that period of time, we saw that new gases were introduced into the atmosphere, and along with that, you also had the evolution of atmosphere, which happened recently in the sense it happened around 600 to 500 million years ago, where the growth of plants thereby started using the carbon dioxide in the atmosphere and started enriching the atmosphere with oxygen. We also took an instance and a certain set of examples to understand how is it that the presence of different gases in the atmosphere also end up shaping the different types of life forms that we experience to be growing around us. And the presence and the enrichment of carbon dioxide, or the enrichment of oxygen for that matter, also significantly plays a very important role in shaping the type of life that you experience on the surface. Now, there after that, we try to understand the greenhouse effect. What is the greenhouse effect? So, greenhouse effect basically, when we talk about the atmosphere in itself, while we took a look at the evolution of the concept of a greenhouse, what is a concept of a greenhouse? But after that, we observed that when we talk about the entirety of the planet, the solar radiation which comes in, that is in the form of a short wave radiation because it has high energy. And with that high energy, it manages to pass through the atmosphere and hit the ground surface or hit the planet surface. Upon hitting the planet surface, the planet also becomes warmer and starts releasing the radiation of its own, what is referred to as terrestrial radiation. And that terrestrial radiation is in the form of a long wave, what is also referred to as a long wave terrestrial radiation, because of low energy that it possesses, because the planet's temperature is not nearly close to what the temperature is what you expect in the region of the sun. Now, that long wave terrestrial radiation, which is imparted by the Earth's surface, because it is low in energy, it is trapped by certain gases such as carbon dioxide, sulfur hexafluoride, water vapor, methane, carbon monoxide, and so on. And that heat is retained by the planet, and that leads to the planet maintaining its temperature even during the nighttime. Now, that is the greenhouse effect. Now, if the proportion of the gases such as carbon dioxide, etc., keep on increasing, that greenhouse effect also increases in terms of its proportion, whereby it does not allow any heat from the surface of planet Earth to be lost into the outer space, and almost all the heat is retained by the planet, thereby leading to further amount of heating as well. Then, after that, We looked at the various different components and composition of atmosphere, where we saw that the atmosphere is actually, if you think about the constituents, can be divided into three major constituents. You have the presence of these life-giving gases, also the presence of water vapor responsible for various different climatic actions, as well as the presence of dust particles which scatter the light and help us see through the darkest of the night with the help of the diffused light that they emanate during nighttime. And also, these dust particles, they become those particular platforms around which condensation can happen, and they lead to even cloud formation by behaving like a hygroscopic nuclei. After that, we understood the concept of a lapse rate, where we observed that under normal conditions, at least in the lower level of the atmosphere, as you move higher up, the temperature tends to reduce by close to around 6.5 degrees Celsius with every change in kilometer that is experienced. So that is where we observe that the lapse rate can also be classified into three types. If, let's suppose, with the increase in height, the temperature tends to reduce, which is normally the case, that is referred to as the positive lapse rate. In cases where the temperature actually increases with the increase in height, what we actually observe in certain conditions, and that is also what is referred to as negative lapse rate and is also known as the condition of temperature inversion. We have not explored the details of negative lapse rate. Why do we experience that? Where do we experience that? We have not explored that. We will explore it in this particular session. Then after that, we also introduced ourselves to the concept of zero lapse rate, where there is no change in the temperature as you move up in height. That concept, again, we are going to highlight again today as we move ahead. We looked at the adiabatic process of cooling and heating, where just by the virtue of change in volume of the air parcel, we experience a change in temperature, where the air parcel can get extraordinarily heated or extraordinarily cooled based upon whether there is expansion or contraction of air. All the application of all these concepts will come in front of us in the next couple of days, and that will further cement these particular concepts for us. Then we had started the study of the layers or the structure of atmosphere, where we had observed that when we talk about the atmosphere, it is divided into various different layers. We have almost homogeneous distribution of gases present right up till the region of mesosphere. And up till that region, it is the atmosphere is also referred to as homosphere because of the homogeneous mixture. And beyond the mesosphere, in the region of thermosphere and exosphere, because you have randomly distributed densities of oxygen, nitrogen, etc., that is also what is referred to as heterosphere, because you have heterogeneous presence of oxygen, nitrogen, and few of the other gases as well. Now, then we started looking at the troposphere, where we observed that troposphere has got a height variation. And troposphere is also the layer having maximum atmospheric density, in the sense, or maximum air density. Because of the force of gravity, almost all the particles of gases, all the particles of water vapor, all the particles of dust, all of them, they are attracted and they stick very close to the Earth's surface. And that is why the density of troposphere is amongst the highest. And then after that, we observe that why is it that you have different height of troposphere in different seasons and in different parts of the planet. And that is largely led by the heating and cooling in different parts of the planet, where we had also observed that when we talk about the region around equator, that is the lower latitudes, these are the areas which receive higher amount of heat, and they are the regions of heat surplus. Whereas the polar areas, they are extraordinarily cold, and that is why these are the areas of heat deficit. So basically, what we do observe under normal circumstances is the fact that around the equatorial region, you have the rise of air in the form of a convective movement of air. And that is why, because there is a rising air column around the lower latitude due to higher temperature, that is why the height of troposphere is also pushed up. Along with that, when we talk about the lower latitudes, the air parcel will be heated because the ground is so very much heated. and that means there is a slight expansion of air parcel also taking place, which further adds to the height of the troposphere. So these are the details that we had looked upon. Today, we shall be initiating the discussion furthermore, and we shall be trying to understand the other various different layers of atmosphere, their basic properties, and then introduce ourselves to the concept of insolation, temperature variation, albedo, urban heat island, the differential heating of land and water. What do we understand by isotherms and the variation in isotherms in various different seasons? And also, we shall be taking a look at the concept of temperature inversion as well. So, that is something that we are going to cover for today. Now, yesterday we had discussed that when we say troposphere, so basically this troposphere is the layer which is closest to the Earth's surface. Now, the end of troposphere is marked by a small region which is referred to as tropopause. So when we say tropopause, it is that zone which demarcates the end of the portion of troposphere, right? Similar is the case with the stratosphere as well. Similar is the case with the mesosphere as well, where the end of each of these layers is demarcated by a pause. So when we talk about tropopause, this demarcates the end of troposphere. Now we'll come to the property of tropopause also. But before that, when we talk about the region of troposphere, we observe that there is a positive lapse rate in this region. So here you will have positive lapse rate. Okay. That means the temperature will reduce as we move higher up in altitude. But what that also means is that you have colder air parcel above and warmer air parcel which is closer to the ground surface. Only then will you experience a positive lapse rate. Positive lapse rate means what? When you move higher up in height, the temperature tends to reduce quite significantly. So here also, when we talk about this region of troposphere, you have the condition where the warmer air is at the lower elevation, whereas the colder air is at top. So here you have warmer air at bottom and colder air on top. This is the layer of atmosphere where majority of the climatic events that you come across, be it the development of a thunderstorm, a cyclone, a rainfall, almost all the climatic phenomena that you come across, jet streams, etc., all of them are experienced in this layer itself. So that is why this layer becomes also very important for us to understand this layer. Now, when you have a condition where the warm air is at bottom and the cold air is at top, there will be mixing of air. In the sense, warm air being lighter will always tend to rise up, whereas the cold air, which is generally heavier, will always tend to sink down. Okay, and listen to this very carefully. So, because you have warmer air at bottom in the troposphere and colder air at top, by virtue of the fact that warm air is lighter than the surrounding and cold air is heavier than the surrounding, you will experience that the warm air tends to rise up and the cold air tends to sink down. Now, that leads to the mixing of air, but we can also say that because of this positive lapse rate, the vertical movement of air will be observed in significant amount in the region of troposphere. So here you experience significant vertical movement of air. Okay, quite significant vertical movement of air is something that you will experience, that you will observe in this situation. Now, let us take a look at the region of stratosphere very quickly, and then I'll tell you about the property of tropopause. So, here, when we talk about stratosphere, this is the layer immediately above the region of troposphere. Now, this is a region having a width or a thickness of, again, close to around 20 to 30 kilometers. But much more importantly, within that entirety of stratosphere, you have a larger concentration in a particular area. You have very large concentration of ozone molecules. Okay. So here, in the region of stratosphere, you have particularly large concentration of ozone molecules. Ozone, again, is made out of oxygen atoms. Just like the oxygen that we breathe in, now oxygen that we breathe in, that is basically O2, right? You have two atoms of oxygen in a molecule. When we talk about ozone, it is basically O3. You have three atoms of oxygen in that particular molecule. So that concentrated area where you will find a lot of ozone to be concentrated, that is what is known as ozonosphere. Ozonosphere. Now, overall, in the region of stratosphere, the density will be very less as compared to troposphere. That is why there will always be a differentiation in existence. But here you have to understand that because you have ozonosphere or ozone layer in this region, that has got its own different properties. For example, when we talk about the solar rays coming onto us and solar rays falling on the planet Earth, now these solar rays, they consist of rays of different wavelength, right? You have violet, indigo, blue, green, yellow, orange, red, infrared, ultraviolet, X-rays. All of these various wavelengths are in fact emanated by the solar rays. Now, these ultraviolet rays, by the way, if they fall upon the Earth's surface, they can be quite disastrous in the sense that when we get exposed to ultraviolet rays, let's suppose the ultraviolet rays of the sun fall upon our skin, immediately you will come across skin lesions, maybe certain cases skin diseases, and it can even lead to skin cancer. Similarly, when the plants they experience the oncoming or the falling of the ultraviolet rays of the sun, there also in the plants also the damage is quite significant. So ultraviolet rays are quite disastrous for the living beings on the surface. That is where this ozone layer comes to our rescue. This ozone layer actually filters out the ultraviolet rays of the sun by re-radiating it back into the space and also by absorbing quite substantial amount of it. So if you think about it, the solar rays which are coming in, let's suppose the ultraviolet rays is what we are talking about. Now, substantial amount of these ultraviolet rays will be absorbed by the ozone molecules, which are present in larger concentration. And that ultraviolet rays, they will basically not only be trapped, some of it will be reflected and re-radiated back into the space also. Now, what this basically means is the fact that ultraviolet rays are being absorbed and are being trapped in the thin ozone layer. Not very thin, because this ozone layer is also of a thickness of multiple kilometers out there. So what is the ozonosphere? Actually, it starts at a height of around 20-25 kilometers in many of the regions. So there you have all these ultraviolet rays which are trapped. So when all that high energy ultraviolet rays are trapped, that means the temperature will continue to increase because these rays will have their own amount of energy associated. So that is why the temperature begins to increase, begins to rise up in the region of ozonosphere. And that virtually heats up the entirety of the stratosphere also, right? So the trapped ultraviolet rays, so here, trapped ultraviolet rays of the sun leads to basically heating of the stratosphere. So as you move higher up in the region of stratosphere, you come across a situation where much more heat is concentrated. For example, if let's suppose you are in this area, you will find that a lot of ultraviolet rays stay there for a longer period of time. So that is why in the region of stratosphere, because of this property, as you move higher up in altitude, you will experience a rise in temperature. And that in itself is what we refer to as a negative lapse rate. So here, because there is so much amount of heat which is absorbed and it is done through the region of stratosphere, so that is why as we move higher up in the stratosphere, the temperature begins to increase. So here, temperature increases with an increase in height. And that is what we refer to as negative lapse rate. Now, here, when we say negative lapse rate, that means what? Colder air is at the bottom, warmer air is at top. Isn't it? That is what a negative lapse rate is. Comparatively, colder air is at the bottom and comparatively warmer air is at top. Now, warm air is always lighter, but here it is already at top. So, where will it rise up? Cold air is already heavier. So, where will it sink? It is already at the bottom. So, that is why whenever you have negative lapse rate in presence, you will not experience the mixing of air or the vertical mixing of air. So that is why in the region of stratosphere, you come across very, very weak vertical motions. So here, colder air on top, colder air at bottom, and warmer air on top. Basically, that means you have no or very weak vertical movement of air. Almost negligible vertical movement of air will be observed in the region of stratosphere. And this is true for the entirety of stratosphere. It is not only restricted to the ozonosphere, but the entirety of stratosphere, you will experience this phenomena. Because you might have the argument that all the heat is being trapped in the ozonosphere. Why is it that here we will experience a negative lapse rate? But the entirety of stratosphere absorbs so much amount of heat that the temperature keeps on accumulating. So when we are at the top of troposphere, the temperature at the top of troposphere, and listen to this very carefully. When we are at the top of troposphere, the temperature is in the range of minus 60 to minus 80 degrees Celsius, depending upon which portion of the planet are we in and which season are we talking about. So because of positive lapse rate, by the time that you reach the top of troposphere, the temperature reduces to minus 60, minus 70, sometimes even minus 80 degrees Celsius. But then comes the stratosphere. Stratosphere is where the heating is observed. So if I take you back to the temperature distribution curve here, observe this. This is the graph for temperature. Now, the temperature on top of troposphere reduces close to around minus 60 degrees Celsius. But in the region of stratosphere, the temperature continues to increase because it is getting heated up. So by the time that you reach the top of stratosphere, you are staring at a temperature of close to around 0 degrees Celsius because there's a negative lapse rate in the region of stratosphere. So now think about the region of tropopause. So when we talk about tropopause, now tropopause is a very thin layer Above it, it is simply a kind of a discontinuity of sorts. So here, above that you have stratosphere, which is heated, and here you have the troposphere, where the top has got low temperature at top. Now, what this basically means is that in the region of tropopause, from the base, you have you have colder conditions which are there, right? Because the top of troposphere is very cold. Whereas in the region of tropopause from above, you have warmer conditions which are prevalent because the stratosphere is very heated up. So you have a mixture of both heat and cold exposure in the region of tropopause. So from above, it is exposed to warmer temperature. From below, it is exposed to colder temperature. That is why tropopause is the one where you will find that the temperature is maintained. The temperature does not change significantly in the region of tropopause. And that is because it is getting cooled down from below, it is getting heated from above. So that is why tropopause also indicates what we refer to as the zero lapse rate. So this is also what indicates a kind of a zero lapse rate. No change in temperature. And why no change in temperature? Because it is cooled down from below and heated from above. No change in temperature. As the layer is heated from above and cooled from below. Okay, hence no temperature change. Now, in the troposphere, we have seen that there will be very strong vertical movement of air because of positive lapse rate. In the stratosphere, we have seen that there will be almost negligible vertical or no vertical movement of air would be observed here. Now, this is something which is utilized by commercial airlines also, or larger airlines, because when you fly from one region to another, you do fly through the portions of the lower atmosphere. Now, let's suppose as you are flying through, now if there is a strong vertical movement of air, either the air is rising up or the air is sinking down, in either of these cases, your plane will experience a lot of turbulence. Larger the plane, greater the amount of turbulence. That is why you will observe that majority of the larger planes, the larger commercial jetliners that you have, the intercontinental travel ones, not the ones that you use for, let's suppose, moving from one particular city to another in our own country, the larger ones. For example, the Boeing 777, 787s, or Airbus 380s, all of these. Now, these are very large planes, so they will be heavily impacted by this vertical motion of air, and they will always feel a lot of turbulence. So, hence, the larger commercial airlines, they have their planes flying in the lower portion of stratosphere in order to avoid any such turbulence, any such vertical movement of air. So this is the reason why majority of the large airlines, they fly through the lower portion of stratosphere. Okay, now here, after this, we come to the region that is mesosphere. Now mesosphere is the layer above the region of stratosphere. Now when we talk about mesosphere, so there again, you have to understand that the you are moving away from the heat source, that is the stratosphere. Immediately below mesosphere, you have the impact of the stratosphere, not the ground surface. So that is why as you move away from stratosphere, the temperature tends to reduce here. So that is why mesosphere will also end up experiencing a positive lapse rate. And that is because why? So here also you will experience a kind of a positive lapse rate. Okay. So, and why is that? Because you are moving away from the heated portion. That is the stratosphere. So let's suppose this is your region or the top of stratosphere. This is, let's suppose, the portion of stratopause. Stratopause. Now above it, you have the mesosphere. So as you move higher up in mesosphere, you are virtually moving away from the stratosphere, which is a kind of a heat source in that area. So that is why as you move higher up, the temperature reduces with height. Temperature reduces with height. So again, here also you have warmer air at the bottom of mesosphere, colder air at the top of mesosphere. Colder air will tend to sink down, warmer air will tend to rise up. So that is why here also you'll find very strong vertical movement of air. So here also vertical movement of air is observed. Movement of air. Right. By the time that you reach the top of mesosphere, you might experience a temperature close to around minus 80 to minus 100 degrees Celsius. So at the top, you might have a temperature of minus 80 degrees Celsius, let's suppose, or minus 90, minus 100. That is the lower temperature. Whereas at the bottom, you have a temperature close to around 0 degrees Celsius. Right. So this is much warmer as compared to the air on top. This is much warmer. So when you have, let's suppose, an object which is falling through mesosphere, it will experience warmer and warmer air as it gets through, isn't it? Because the lower portion of mesosphere is very hot, upper portion of mesosphere is cold. So as if an object falls through the portion of mesosphere, it slowly and steadily experiences more warm air. That is why all the space debris, and even meteorites for that matter, when you experience that they burn up in the atmosphere itself, they generally burn up in the layer of mesosphere. Okay, so that is why majority of the space debris, majority of the other celestial objects which keep a meteor shower, etc., and meteors and meteorites, they end up burning up through the region of mesosphere, because as they enter through the mesosphere, they start experiencing the resistance of air and warmer temperature also, due to which very high heat, they end up burning in the process. So that is the portion of mesosphere. Having said that, when you consider all the various layers of atmosphere, mesosphere is the one which is very less understood. Very little is known about mesosphere because, as I told you yesterday, at this particular height, you cannot have airplanes which can travel at this particular height, right? So we cannot gather information and data with the help of the airplanes. Similarly, you cannot have the condition where the satellites will move into this area, because this is at a lower height and satellites, they generally are in motion at a greater elevation. So that is why the only source of information that we have available about the mesosphere is with the help of experimental sounding rockets that are launched by the various different space agencies, and thereby trying to gauge an idea about what this particular layer is about. Now, just to give you a context of something that we studied in geomorphology, we studied in geomorphology that during the case of a volcanic eruption, there is massive release of smoke and cloud of dust. That is something that we studied, isn't it? Now, I had been telling you that the Tonga eruption, which continued from December 2021 all the way till January 2022, that Tonga eruption was amongst the most massive volcanic eruptions experienced by the planet in the recent past. Just to give you a factual trivia about it, when you had that Tonga eruption which occurred on 15th of January 2022, the cloud of smoke which was created and the force which was created, that cloud of smoke is said to have reached the region of even mesosphere. So think about it. What is the power that a volcanic eruption has? It has the power to inject these gases and clouds even high up in the region of mesosphere. Now, after that, we come to the layer above or the region above mesosphere. Now, in the region above mesosphere, as I told you, you don't have a homogeneous distribution of oxygen, nitrogen, and other gases. You have a very heterogeneous mixture which is out there, but you have certain particular densities of oxygen, certain particular densities of nitrogen and other gases also. Now, we can also say that above the region of mesosphere, you virtually experience an unadulterated rays of the sun falling on the top of the mesosphere, isn't it? Because as the solar rays they pass through mesosphere, stratosphere, and troposphere, they get filtered out, they get moderated. But above the mesosphere, you get quite unadulterated rays of the sun. So that region above the mesosphere up to a height of around 400 kilometers, that is what is also referred to as ionosphere. Ionosphere largely exists in the region of thermosphere itself, because thermosphere in itself spreads for many hundreds kilometers, and it does not have a demarcated end that this is the end of thermosphere and this is where exosphere starts. Density of gases keep on reducing till they merge with the outer space. So, in the region immediately above mesosphere, where the unadulterated rays of the sun they fall upon the molecules of oxygen and nitrogen and other gases also, they end up exciting those particular atoms. Exciting means, for example, any particular atomic structure that you have, when it receives a lot of energy, when it receives a lot of energy out there, you might have an electron which jumps the ship, right? You might have an electron which jumps the ship. Why? Because of higher amount of energy. So as the electron jumps the ship, this will gain a polarity, a charge of positive. Someone or some gases might develop negative charge. So you have the presence of charged particles in the entirety of the region. And those charged particles are created purely by the unadulterated and the powerful solar rays. Now, because the charged particles, they are also referred to as ions. I hope we have heard about the name ions. So charged particles, they are also electrically charged particles are also known as ions. And in this layer, you will find the ions to be in greater density. That is why this is a layer which is also known as ionosphere, where you have the presence of charged particles. Okay. Now, these charged particles, they basically re-reflect back the radio waves emitted from the Earth's surface, and they help in facilitating the radio communication carried out. Nowadays, radio communication is not that very common. Nowadays, generally, you go for satellite-based communication. Even the mobile telephony, etc., that you carry out, that is all based on satellite-based communication. But not so time or not a long time ago back, if you ask your parents or your grandparents, they would have used a lot of radio, right, as a mode of entertainment for that matter. So when you use the radio, basically use the radio waves which are emitted from a region and are received at another area. Now, there, if you ask your parents, in case you have not used the radio yourself, if you ask your parents or your grandparents, whichever is more convenient for that matter, that you would have observed that, or they would have rather observed that during the cloudy nights or during the cloudy conditions or during a condition of a storm where you have a lot of clouds, etc., very thick clouds, etc., or rainy conditions are prevalent, they would always come across a situation where, let's suppose, they would catch some other radio station. A cross connection would happen, right? Radio Pakistan would be heard in India, all India radio would be heard in Pakistan, and similar is the case with Nepal, Bangladesh. So there would be a lot of cross connection also, which would be happening. And that is because of the basic property that the charged particles which are present in ionosphere, they reflect the radio waves. Okay, so charged particles, presence of charged particles. ensure the reflection of radio waves and facilitate radio communication which is carried out. That is why in the region of ionosphere, you come across a scenario where, let's suppose, this is what we consider as the ground surface. Okay, let's suppose here you have the ionosphere with the presence of all the various different types of charges. All the different types of charges, let's assume, are present here and are spread over. Now here, they will reflect back the radio waves of communication. So let's suppose how it works is that if you have a kind of a station, radio station. Now what they do, they emit waves, radio waves. Now radio waves, regardless of their wavelength, when they encounter these charged particles reflect them back. And these charged particles, they are virtually then captured, or these reflected radio waves are then captured by the receiving station. They are captured by the receiving station. Right? And you get to understand, or you get to receive the radio signals and facilitate communication thereby. However, when we talk about very thick clouds, you can have clouds which can be more than 10 kilometers thick, right? As we will study later. So when you have these very thick and very dense clouds, now that also leads to the presence of charged particles. Generally, larger clouds have the presence of a lot of charged particles. So let's assume you had a situation where you experience such a kind of a cloudy night in existence, right? Where you have a lot of cloud cover. So cloud cover will also have the various different charge. So that is why in these conditions, the radio waves again encounter the charged particles and they will be reflected back here itself, leading to cross communication or miscommunication also. That is why the communication of radio waves is actually disturbed when you have these cloudy nights. That is why the world has virtually moved on to satellite communication. The various different satellites that you have, different categorization of satellites that you study in science and tech. So that satellite communication ensures that this radio communication is not required that much anymore. Okay. Now, satellites are present above this zone, above this particular zone. Okay. Now, after this, we come to the factor of insolation and then temperature. So, when we talk about the concept of insolation, what is the term insolation? What is meant by insolation? Now, many of you I have seen previously, you confuse insolation with this term, insulation. I've seen many of you confusing it, that it might be a misspelling or a wrong spelling, but both are same. Both are very different. Both are as different as they can be. Insulation is very, very different from insulation. Insulation is what you provide with certain materials where they don't allow heat and electricity to pass through them. That is insulation. But when we talk about insolation, that basically tells us is the amount of solar radiation received on a given surface in a given time period, right? So for a particular duration, right, any particular duration where you want to carry out the study, the amount of solar rays which hit the ground surface, the total amount of solar radiation received on the ground surface, that is insolation. Now if I ask you a question, just by pure and simple logic, insolation of the sun, or solar insolation as it is referred to, Will it be equal in different parts of planet Earth, or will it be variable in different parts of planet Earth? What does your logic tell you? Will that be absolutely the same in different parts of planet Earth, or will it be variable? Very good. It will be variable. Different parts of planet Earth, they will experience different amount of solar rays coming in and different intensity of solar rays coming in. For example, when you actually, I don't know if anybody has basically engaged in the activity of trekking. Most of you would have carried out the adventure activities, carried out trekking exercises, etc. So when you go to the top of a mountain or a hill, you feel as if the sun is beating down even harder, right? If you ask any of your friends who have actually been to mountaineering expeditions, not trekking but mountaineering expeditions, where they actually climb up the snow covered peaks, etc., there you will find that they have to necessarily cover their skin at that particular height, or they will get burnt by the sun or the solar rays. So that is how powerful it is. So insolation in different parts is variable. It varies. Sometimes it can impact temperature, but you have to understand that temperature is not directly proportional to insolation. It can be the case where the solar insolation received in an area is high, but that region receives or experiences lower temperature. It can be the case that the amount of insolation reaching a particular area is comparatively low, but it will experience a higher temperature. So, insulation is just one of the factors which can influence temperature, but temperature experienced in a place is dependent on many of the other factors also. So, just because a region experiences higher amount of insolation does not mean it will have a very high temperature also. So, let me write this down as well. So, just one of the factors which influences temperature. Temperature is determined by a combination of many factors. And we'll come across it. We'll come across the various instances that we move across, that how, despite having a high insolation, the temperature is not very high. For example, the top of the mountains, the amount of insolation received is very, very high, but the temperature is not so high. Similarly, when we talk about the different sides of mountains, you have different amount of insolation. So that is something we will take a look into. But before that, you have an image on your screen. Now, because we are going to read climatology in quite significantly greater detail. So, what this image tells us is basically a small weather station where all the periodic readings are carried out. And eventually, all the data that you see, that today the temperature is 42 degrees Celsius, the humidity is, or the wind pattern or the wind flow is this much, the amount of rainfall received is this much centimeter, etc. All that observation is carried out in these small weather stations. So what you see here, suspended around 1 to 2 meters from the surface, that is what is a thermometer, air thermometer. Now, it is not like your thermometer that you stick under your tongue and you measure your temperature. It is not that kind of a thermometer. It is a different thermometer. But it is not kept on the ground surface. It is rather suspended at a height of 1 to 2 meters from the ground surface, so as to ensure that there is not great amount of variation in air temperature depending upon the ground surface. There is not much impact of the ground surface temperature into the air temperature. That is why that thermometer is actually suspended up in the air. Then, what you have here in the form of these cones, and semicircular cones. This is what is an anemometer. Anemometer. It basically measures the wind velocity. Stronger the wind movement, greater will be the circulation. So measures wind velocity. Then you have also got a rain gauge. So when we talk about a rain gauge, it is used to measure the amount of rainfall received. You would have heard about the term that this region has received 10 centimeter of rainfall, 5 millimeter of rainfall, 20 centimeter of rainfall. So how do we get to know about that? That how much rainfall has been received in various areas. That is with the help of an installation you would have studied in your childhood days. That is your rain gauge. So when we talk about a rain gauge, it is a simple structure, cylindrical structure. Okay, a kind of a simple cylindrical structure where on top you have a funnel which is actually installed here. A kind of a funnel is put here. Okay, and basically that funnel leads to this cylindrical structure. And this cylindrical structure has got various different markings. Okay, so all the water which is accrued due to rainfall. So why do we have that funnel? Why directly can't we have the cylinder for accumulating all the water? That is because of a very simple logic. Let's suppose you have a cylinder, or even what you experience with a mug or a bucket. So if you have a bucket full of water, you keep it out in the rain and it rains, you'll find that various drops they are formed and various different splashes are created when the raindrops fall on water, and few of those splashes can virtually go out of the bucket as well. So that is why in order to capture all the water which is falling in that area, you have that funnel like structure so that it doesn't splash and move away. Now all that water virtually trickles down, and eventually whatever water is accumulated, you give the reading that this much centimeter of rainfall has been experienced in this particular area. So that is the case of the rain gauge. Okay, and this is how generally a weather report is furnished in any particular region. Now we come to the factors that cause variation in insolation in different parts of the planet. As we have talked about the fact that the insolation is not consistent. So, what are the various factors? The first important factor is the angle of inclination of the Earth. So, Earth is basically tilted on its axis and it is a spherical object. So, in different latitudes, you experience different angle with which the solar rays they come upon. So that also varies the intensity of solar rays, the power of the solar rays which fall upon, and that also leads to a variation in terms of insolation. Then, revolution of planet Earth. Now, planet Earth revolves in an elliptical orbit around the sun, and we have seen that in its entire movement around the sun, you have a condition of aphelion, where the planet is farthest away from the sun, having a distance from the sun close to around 152 million kilometers. And we have also seen that there is a position of perihelion, generally experienced on 4th of January, where the Earth is closest to the sun and where the distance is around 147 million kilometers. So a variation in that 4 to 5 million kilometers, that also brings about a substantial or a slight change in insolation, even though it does not influence temperature to that extent, but it does lead to a variation in amount of insolation experienced here also. Then configuration of the land. In the sense, this what it means is that the direction in which the land is facing. And here you might have a question, but all the land faces upwards. What are we talking about direction? So let's suppose a mountainous area, a highland area. So a mountainous area will have different slopes. Which of them is directly exposed to solar rays and which of them gets lit by solar rays indirectly. Okay, so here direction of land features such as mountains, such as mountains. Okay, so that is basically the configuration of land, and it also ends up determining the variation in the amount of insolation. And then comes the factor of altitude. With the variation in height, the amount of solar insolation also ends up varying. Let us take a look at each one of them one by one. Okay, right. So just a moment, guys. Um, we'll be back in a minute. Just a moment. Okay, now a confirmation about the audio. Audio is working fine. Thank you. Now, here, when we talk about the factors influencing the insolation, the first major factor is the angle of inclination of the planet on its axis. So, the planet is tilted on its axis from vertical by an angle of 23.5 degrees. Right, that is the tilt of the axis. Now, here, how does that variation in insolation end up happening? So, for that, let us take the case here of an experiment, the very famous torch experiment that you can talk about or that you might have heard about. So, here, let's suppose I have a torch, the older ones, the ones that you generally would associate with your grandparents, right? Where the torches would be so heavy, you hit someone with a torch and their work is done. Not the modern day torches, which are quite light and gentle for that matter. So, here, if you have those kind of torches, the older ones, they emit significant amount of light like this. Let's suppose I keep a particular torch in an inclined position here. Yes, the ever ready ones. I'm sure you guys would have seen that torch. If you have not seen those kind of torches, you are missing some good fun in your life. So that is basically here. Now, this particular torch in this position will also emit light, but this light will be quite distributed or dispersed, right? Now, if I ask you about this location A, and if I name the position of the torches as position 1 and position 2, now A will receive greater amount of energy in which position? Position 1 of the torch or position 2 of the torch? What do you think? Which way, under which condition will A receive greater amount of energy? Right? This is an easy one. A will receive much more amount of energy when the rays are shining vertically above it, isn't it? So here, when the rays are shining almost vertically, almost in a perpendicular position, that is when A will receive greater amount of insolation. That is why it is during right now also within a few minutes, or maybe in certain areas already, you experience the sunrise. And in the early part of the morning, that is around 7 a.m., 8 a.m., 8:30, 9 a.m., almost up till 10 a.m., the sun is not vertically overhead above you. The sun is slightly in a slanting position, right? Even at that point of time, when the sun is in slanting position, you feel comfortable walking out. It is not as if you say that, okay, the amount of heat is simply atrocious. No, it is tolerable. But when the sun comes overhead around 1 p.m., 2 p.m., 2:30 p.m., that is when stepping out becomes almost impossible. Have you ever thought of it? Why? That is because when the position of the sun is in a slanting state, right, where the location of the sun is in a slanting state closer to the horizon, there the solar rays, they have to cover a larger distance in the atmosphere. This distance that they have to cover is going to be very large. And when they have to cover a larger distance in the atmosphere, means what? Atmosphere will in a way reduce the impact of it, isn't it? So direct rays of the sun, wherever they are falling, they will receive very high amount of energy, high amount of insolation. Slanting rays of the sun, wherever they are received, very little amount of insolation, very little amount of heating is observed. So here, now if I can bring your attention to this particular image, observe this image here. It is the condition of the situation where the southern hemisphere, if I mark this as the equator, you can see that the southern hemisphere is tilted towards the sun. So observe around the region of Tropic of Capricorn, the solar rays are almost perpendicular. So insolation will be very high. Here also, the solar rays make a very significantly larger angle. Again, that means amount of heating and amount of insolation will be high. Observe in the region of Tropic of Cancer, it starts becoming very slanted and tilted. That is the time when the northern hemisphere experiences winter months. Then observe here in this case. In this case, it is almost horizontal. So very little amount of energy will be received. That is why even when we say that during these months, Antarctica, during the months of November, December, January, February, Antarctica does not experience nighttime, experiences continuous daytime. Does not mean there will be much heating of Antarctica. Does not mean that Antarctica will attain a temperature of 30 degree, 40 degree, or even 10 degrees Celsius for that matter. And that is because throughout that time when the solar or the sun is exposed in Antarctica, it will be at a very slanting position, not much of an energy. So that is why direct rays of the sun, wherever they are received, there we can say that the amount of insolation is higher. And as we move to the higher latitudes, the amount of insolation reduces. So lower latitudes, lower latitudes means closer to the equator, receive direct rays of the sun, and hence higher insolation. Higher levels of insolation. Whereas when we talk about here higher latitude areas get slanting rays where the solar rays have to travel a larger distance in the atmosphere. Hence, lower insolation. Lower insolation. Okay, hence you receive lower amount of insolation in the higher latitudes. That is why in the higher latitudes, generally, you don't receive that much heat. The amount of heat that we receive, for example, in India, you don't receive that heat in the high. For example, even within India, when you talk about the regions such as, let's suppose, Kanyakumari, right? You go out there, visit that place, fair enough. As long as you are closer to the sea, you will experience the winds moving in. But let's suppose you go slightly inwards into the region of Tamil Nadu or Kerala, away from the coastline. You will experience the solar rays beating down upon you as if they have a vengeance. But furthermore, go to the region, let's suppose in Himachal, Jammu Kashmir, even Ladakh. Now, there you will observe generally, Ladakh is a different matter because of altitude, but generally there you will receive that the solar rays are much more tolerable because you are moving towards higher latitude, the solar rays are already inclined. So, when we talk about the actual tilt of the planet Earth, the actual tilt ensures that during the winter season of the north, the sun shines vertically over Tropic of Capricorn. During the summer season of the north, the actual tilt is such that the sun shines vertically over the region of Tropic of Cancer, not beyond that, either in either of the hemispheres. Okay. Now, after this, we come to the revolution of planet Earth. So, when we say revolution, we do know that the planet moves in a kind of an elliptical orbit where one position, which is experienced on 4th of January, the Earth is closest from the sun. And at one position, which is experienced on 4th of July, the Earth is farthest away from the sun. So here, that distance variation also brings about a variation in insolation. But that does not bring about a substantial change in temperature. And why is that? Because the actual tilt here, for example, in this position, let's suppose the Earth is in this position. So, actual tilt in this position ensures that the southern hemisphere is exposed to direct rays of the sun. So, southern hemisphere will experience summer, and northern hemisphere, because it is tilted away from the sun, it will experience winter. But when we talk about this position here, when the Earth is farthest away from the sun, you will observe that the northern hemisphere is tilted towards the sun and the southern hemisphere is tilted away. So that means northern hemisphere will experience summer. So despite that variation in insolation which is observed, there is not much variation observed in temperature. Okay. So here, when we talk about the revolution of Earth, greater, slightly greater, not significantly greater, slightly greater amount of insulation is observed during perihelion as compared Yes, Shazia, you can draw this image for answer writing also. Try to draw as many images for answer writing as compared to aphelion. However, however, this does not have much of an impact on temperature due to other factors such as the tilt of the planet. Okay, so this is another factor which leads to variation in the amount of insolation received in different parts of the planet. Other than that, you have other set of factors. For example, you have the factor of in which direction the land is facing. So here, before I bring you to these images, and these images before they confuse you, let us talk very basic here. And when we talk very basic nature here, let's suppose this is the actual tilt of the planet. Let's suppose, right? These are where the solar rays are coming from. We consider mountainous area in the northern and the southern hemisphere both. So when we consider the Himalayas, imagine the Himalayas for a moment. Himalayas spread all the way from the northwestern part of the country, from the region of Jammu Kashmir all the way till Arunachal Pradesh. So we can say that the Himalayas spread from east to west, right? So this Himalayan mountains, they will also have a northern face facing the north, that is towards the region of China and Central Asia, and it will have a southern face also, that is the one which faces the rest of the country. So Himalayas will have a northern and a southern face. Similarly, Alps will have a northern and a southern face. So let's suppose we consider a mountain here, even though way out of proportion, but just to make you understand, no mountain can have such a kind of a proportionality of shape when you consider the size of the earth like this. But still, we can say that this will be the northern face, this will be the southern face. Now, if I ask you a basic question, out of the northern and the southern face here, which will experience greater amount of solar insolation, greater amount of energy will be received by which one of them? Northern face of the mountain here or the southern face of the mountain here? What does your logic tell you? Southern hemisphere? I'm not talking about hemisphere here. Southern face, right? It will be more direct rays of the sun will be falling on the southern face, isn't it? So, this is the reason why when you observe the Himalayan stretches, and if from now on till the time that you cover the portion for examination or you appear for the examination, you will have a lot of time to come across current affairs about the various settlements, various different cities, etc., where they are located. You will find majority of the settlements, they lie in the southern face of the Himalayas. Majority of the settlements. And that is because as they receive more direct solar rays, as they receive greater amount of solar insolation, there is a slightly warmer temperature created. And that is why the region becomes habitable, tolerable. Northern faces, in this case, they are the ones where lesser amount of solar insolation is received, so lower temperature is experienced. That is why more people, they prefer to live on the southern face of these mountains. Even for that matter, if you take the example of Alps also, if you take a look at the alignment, there also you will have a distinct northern and the southern face. And it is the southern face of the Alps, which is quite significantly populated. Northern face, not so much. So the direction or the configuration of the land What is the alignment, the orientation of the land? That also ends up determining the amount of solar insolation. For example, even in the southern hemisphere, let's suppose I have a mountain here, right? Or let's suppose I have a mountain like this. Now, here also you will have a northern face and a southern face. In this case, the northern face will receive direct rays of the sun, right? The southern face will not receive that much amount of energy as compared to the northern face. So, depending upon what is the direction of the land, they experience different amount of solar insolation. Okay, so this is a very simplistic image that you can draw for this. So if let's suppose the sun is present at the region of equator, in the northern hemisphere, always the southern slope of the mountain will receive greater insolation. In the southern hemisphere, always the northern slope will receive greater amount of insolation. And the location of the sun, the apparent position of the sun, varies from the region of Tropic of Capricorn during the month of the winters to the region of Tropic of Cancer. So if let's suppose we talk about Himalayas, Himalayas are situated to the north of Tropic of Cancer, isn't it? So always it is the southern face of the Himalayas, regardless of whichever position of the sun we are talking about. Southern face of the Himalayas will always end up receiving direct rays of the sun. Okay, I hope that is understood. And then I will take a few questions. After that, we come to I'll take cover this portion and then I'll take a couple of questions. So here, then we have the factor of altitude. Variation in altitude also leads to variation in terms of solar insolation, and that is purely because of the fact that when the solar rays they have to hit the ground surface or at the sea level, they have to travel a greater distance in atmosphere, which adulterates them, which lowers their intensity. So if I give you an example here, let's suppose this ground is at sea level. Let's suppose this is a region of the plateau. Let's suppose we are talking about the plateau region such as the Tibetan plateau or the Tibetan highland, which are at an altitude of 5 kilometers or more. So here you have the atmosphere. This is at an elevation of 5 kilometers. So here, when the solar rays they have to reach this position as compared to the solar rays which have to reach this position, you will observe that in the second case, the solar rays have to travel through larger number of atmospheric particles. So their intensity reduces by the time they reach the sea level. So intensity reduces by the time solar rays reach the sea level. The intensity substantially reduces. It is a different matter altogether that with height, the temperature reduces. When you go to the top of mountain, it becomes very cold, but does not mean that it receives lesser solar insolation. That is why when you go at high plateau regions or high altitudes, there is always a fear of sunburn, right? Now please don't have an analogy, because I have students who come to me with this and they write long mails about it, that you said that with altitude we will experience sunburn. Just now I went to the top of or my building's terrace and I did not experience sunburn. Amount of heat on my building's rooftop is the same as the ground surface. I'm not talking about that slight variation that I go up 3 stories and suddenly I will get burnt by the sun. No, I'm talking about a substantial variation in height, substantial variation. Let's suppose 5 kilometers. In case of the Himalayas, even 6 kilometers and more. Right. Now, that is why you will find always majority of the mountaineers, while they do suffer from the various different aspects of hypothermia, etc., many of them, they suffer from a very severe degree of sunburn, something that you won't experience on the ground surface. Okay, so this is basically the case of variation in insolation. Okay, now I'll take 3 to 4 questions along the way, and then we move across to the concept of albedo. So, is it one of the region for Shivalik Himalayas? Is vegetation is high? So that has got to do, Balraju, with the aspect of height also, because lower the height, higher the temperature. And as you go to the Great Himalayas, it has very low temperature. So trees and plants do not exist in very low temperature. That is one of the reasons. Shazia, if in aphelion the Earth is farthest from the sun and January the Earth is closest to the sun, that is what I had told you, Shazia. Aphelion, the Earth is farthest away from the sun, but still in the position of aphelion. If you notice here, the actual tilt is such that the northern hemisphere faces the sun. So northern hemisphere will experience daytime for a longest duration as compared to southern hemisphere. That is why it will be summer in the northern hemisphere, it will be winter in the southern hemisphere. Here, despite the fact that the Earth is very close to the sun, not very close, there's a variation of 4 million kilometers. Despite that fact, here you will observe that the northern hemisphere is tilted away from the sun. So that is why it spends maximum amount of time in night phase, when the earth loses its heat. It is during the day that earth gains its heat, and during the night the surface loses its heat. So regardless of how close it is, if it spends majority of the 24-hour period in night time, it will be losing heat, it will be colder. Okay. Sham, so the summer or winter experienced by the southern hemisphere is more than the summer or winter received by the northern hemisphere, because the summer or winter experienced by the southern hemisphere is more. What do you mean by more? As in the temperature aspect of it, or if you are talking that the winters are much more colder, etc. Understand, temperature is a sum product of many of the factors. Many of the factors, including the movement of winds, the rate of evaporation in a region, the amount of moisture present in the air, many of the how close you are to the sea, many of these factors, the type of ocean currents which are in existence in the region, many of the factors are responsible for the variation in temperature. So it would be improper for us to think about only insulation as a determining factor. But still, I would be interested or curious to know, what do you mean by saying that experienced is more? What about the Aravallis, east or west face? No. See, Aravallis, they are in a north-south alignment, right? So east, as the planet is rotating, both east and west face will receive the rays of the sun. But it is the northern and the southern face of the Aravallis, or the northern tip or the southern tip of the Aravallis, there will be a variation in insolation. And there also, Musharraf, in fact, if you have to think about it, as the planet rotates, initially it will be the eastern face of the Aravallis which will receive more solar rays. And as the planet rotates in the afternoon, evening time, it will be the western face. So apply the logic there. What is the zenith that mentioned in the diagram? Zenith means the top. Okay. And how does the tilt of the Earth's axis matter to our weather? Because you get exposed to greater amount of solar rays for a larger duration of the day, or you spend larger duration of the day during night time. So take a look at the first module of the entire geography session, where we had talked about the various seasons. Why do we experience various seasons? You will get a clearer idea about that. Dikshit, could you please tell me, warmer air have lower density and colder have higher density? Then how can colder air is above warmer air in tropopause, in mesosphere? See, just because you have a variation in density by virtue of temperature does not mean that the colder air is so very heavy on top, it will immediately fall to the bottom. Understand anything that, regardless of anything, you have to understand mesosphere is colder as compared to troposphere. But will the density of gases in mesosphere will be higher than troposphere or lesser than troposphere? What do you think? The density of gases will be lesser in mesosphere, right? Because with a extension of height, the gravitational force also reduces. isn't it? And the only reason we have colder air on top in the region of troposphere is because of the fact of a positive lapse rate, where because you have more particles closer to the ground surface, they will retain that heat. Once they get heated up, they will rise up. And in the meanwhile, a convection current will be in existence where the cold air will replace that warm air from the bottom. So that is why a continuous mixing of air takes place. It is not as if in stratosphere, cold air is, or in the region of troposphere, the cold air is fixated at the top and the warm air is fixated at the bottom. They keep on mixing. That is what brings about the air circulation and the wind patterns across the entirety of the planet. Okay, and Shalu, for example, equator do not experience higher temperature, although high insolation due to cloud cover and rain. Yes, correct. Himani, why doesn't the snow melt on Himalayan peaks, if solar insolation increases? Because again, I will repeat, and if you want me, I can me to write it somewhere else in a fresh slide. I will write it there also. Insulation is just one of the factors which influences temperature. Temperature is determined by a combination of various factors. If you wait for a few moments, I'll tell you why at the top of the mountains the temperature is less. Right? So, despite the higher insulation, it can have a lower temperature also. Okay? I hope that is understood. And Yasmin, yes, it is genetic a bit, and because of how the melanin secretion happens with the height that ends up varying with the amount of insulation that varies. You'll find generally people living in the hilly areas, in high hills, they have a variation over a period of time, even in their basic genetics, in terms of the amount of RBCs that their blood has, in order to compensate for lesser amount of oxygen at a higher altitude. So there is a kind of a significant variation. In North Sikkim, insolation is less. Yes, correct. And for the ozone, the reason for negative lapse rate in stratosphere, it is all the heat, Sarthak, which is trapped by the ozone layer and amongst the ozone molecules, all that heat which is trapped, that is what increases the temperature. Chandu, the size varies. In the case of rain gauge, the size tends to vary from one region to another. And Biswajit, then why mountain tops are cooler than the ground surface? Wait for some time. Subramania, from previous analogy, consider ground surface has more heat. Here, we consider only receiving of light. Just an example of how the energy travels. If it is perpendicular, more concentration of energy in a region. Okay. How tropopause get heated from above, that is the bottom of stratosphere. Bottom of stratosphere, it is colder as compared to the top of stratosphere, but it is comparatively warmer as compared to the top of troposphere. That is why you have a simultaneous impact of hot and cold conditions. Okay. Please explain why southern face of landform in northern hemisphere will always receive higher insolation. Pratik, it is in a way, if you think about this particular situation, let's suppose you have a particular mountain like this with a northern face and a southern face. If the position is sun of the sun is here, which face will receive more direct rays of the sun? Will this region receive more direct rays of the sun? Obviously not. So here it will be the southern face. In case you can also have a situation where when we talk about the region of southern part of India, in southern part of India, you can have a situation where the sun can virtually be overhead. So in that case, both the faces will receive equal rays of the sun. So depending upon the position of the sun, which is the face of that landmass which is facing the sun directly, obviously that will receive more direct rays of the sun. Okay. And yes, Ziba, you can conclude that. And Sahil, I think this was your question as well. Is there any other impact of tilted Earth rather than change in seasons? The variation in the length of day and night also. Why doesn't the snow melt on the Himalayan peaks? So the same question. Is there any? Okay. So all the same questions are being repeated. Ionosphere consists of thermosphere and exosphere, only thermosphere. Uh, we heard so many times that rainfall is 10 centimeter. That means for how much time? It depends. It can also be 10 centimeter in a day. That can create havoc. It can be 10 centimeter in a month also. So it depends what time period is being referred to. And how can we experience sunburn as we go high as the temperature reduces? Because of the intensity of the solar rays. Sunburn is not experienced with high temperature. If ever you have that confusion, sit inside your room during the warmest of the summer months when the temperature exceeds 40-45 degrees Celsius. You will not get sunburn by sitting in your room, will you? Step outside, you will get that sunburn. Why? It is the intensity of the solar rays and that energy imparted by the solar rays that creates that reaction on the skin. It is not sheer by temperature. Okay. So all those who had the confusion that sunburn is because of higher temperature, that is not the case. Are we not going to study about? There is not much to study about the thermosphere and exosphere. The important part to study in thermosphere is only the presence of ionosphere. Other than that, thermosphere virtually has a heterogeneous presence of gases. It will have a very high amount of energy, each of these particles, because unadulterated rays of the sun hit them. And slowly and steadily, as you move higher up, they dissipate into outer space, into the region of exosphere. Okay. Do beaches get higher insolation? Not as compared to the other areas. The altitudinal variation in Himalayas are greater than the eastern half. Altitudinal variation of Himalayas are greater in the eastern half. What do we mean by altitudinal variation? Because you have high mountains even in the west, even in the east. Okay, and at Guru Shikhar, I experienced sunburn in spite of very low temperatures. Yes, that happens. And above ionosphere, temperature is in negative lapse rate. Atharv, that is because in thermosphere, why the temperature increases quite significantly is because the particles, they are not present in higher density, in very great density, but they are hit by very high energy rays of the sun, and that is what increases their temperature. Okay, and I think I have answered all the question. Why tropopause temperature is not affected factors such as seasons and all? It is affected. The height of tropopause, in fact, is impacted by the rising and the falling air. But the reality of the matter remains the same, that the tropopause, beneath it, you have cold conditions of the troposphere, and above it, you have warmer conditions of the stratosphere. So that is why zero lapse rate. Okay, right? So now we move ahead with the concept of albedo. Do you need a break before that? Okay, fair enough. So we take a break and we'll be back in around. Sandeep, if you are facing any of such issue in that subject that you have mentioned, it won't be proper for me to tell that. If you're facing any such issue, please send a mail to me, and you have my mail ID. Write a mail, and we'll try to understand what the issue is, first of all. So, can we take a break at 8? Are we all on board with that? Right? Perfect. Perfect. So, let's continue till 8, and at 8, I will give you a break. So, now we come to the portion of albedo. Now, albedo, basically, what is albedo? So, I have two images in front of you. One is that of a snow covered peak, another is of a marshy floodplain, right, where you have presence of grasses, mud, and some amount of water as well. Now, if I ask you just by your general visual approach, if I name this region as A, if I name this region as B, right? General visualistic observation, which will reflect solar rays more, A or B? Which will cause greater amount of reflection? Always A, isn't it? Always A will be able to reflect more amount of solar rays. Why is it so? Because of the nature of the surface. Here you have the ice covered and the snow covered peaks, whitish in appearance. They will reflect more. Here you have a darker appearance, absorb more. So, what we come from, or what conclusion we can derive from this is, depending upon the nature of the surface, what characteristic the surface has, you have different amount of solar rays which are reflected back. Now, any surface, when we talk about, you have different types of surface. For example, basaltic rocks, right? They are darkish in appearance. Felsic rocks, brighter in appearance. The felsic rocks rich in silica. Basaltic rocks rich in iron, magnesium, poor in silica. Now, all these materials, all these surfaces will reflect different amount of solar rays. For example, something that you can relate to your day-to-day lives. During the peak of the summer, I know that the summer has passed over, but during the peak of the summer, especially, and in fact in summer almost all the parts of the country we experience the same amount of atrocious conditions, so not much of a difference there. But if ever you step outside your house around 2 p.m., 3 p.m. in the afternoon, 2:30 p.m. in the afternoon, and let's suppose you observe the temperature of the road which is covered in black asphalt, etc. If ever you put your feet on the road, or if you ever have to put your fingers on the road, it will be burning hot. You would have experienced that. It is burning hot. But let's suppose your house in itself is painted white from outside or a brighter color from outside. During the same peak of the day, if you touch that whitish wall, it won't be that hot. Why? Because it will reflect those solar rays. Whereas the darker road, the concrete structures, they will absorb greater amount of solar rays. So the property of any surface to reflect some amount of solar rays and absorb the rest, that is what we refer to as albedo. So albedo is also referred to as the reflective quotient of a surface. And the reading of the albedo varies between 0 to 1. An albedo of 0, a surface, let's say, indicating an albedo of 0, means that it is absorbing everything, reflecting nothing at all. A complete and an ideal black body, right? And then if the albedo is 1, that means it is reflecting everything, absorbing nothing. That means a complete and an ideal white structure. So that has got an instrumental role to play in the variation in temperature. That is why when you observe the Tibetan highlands are at an altitude of 5 kilometers from the sea level, from the sea surface. Your normal logic should tell you that these regions of Tibetan highlands should be very cold, which they are. During the winter months, they are very cold, covered under ice and snow. But come the summer months, come the months of June, July, and August, Tibetan highlands, they get heated up much more than their surroundings. In fact, Tibetan highlands and their heating is one of the important factors which contributes to the strength of Indian monsoon. And why does that happen? Because it is made out of basaltic rocks. And these basaltic rocks, basically darker in appearance, any object which is darker in appearance will absorb greater amount of heat. That is why even we are basically many of the times advised, recommended that when it is summer, try to wear brighter clothes. Not because you look good, but because of the fact that the brighter clothes will reflect majority of the solar rays. So less amount of heat. And during the winter season, always advisable to wear darker clothes because it will absorb that heat. Something very similar is experienced on the ground surface also. So when we say albedo, it is the portion of the solar energy reflected from the surface of the Earth back into space. It varies between 0, means no reflection, to 1, meaning complete reflection. Complete amount of reflection. Obviously, ideal conditions don't exist in the nature. So obviously you won't have or you won't come across any surface with an albedo of 1 or an albedo of 0. When we talk about the ice covered areas or the snow covered regions, they will have an albedo close to around 0.85. Means what? 85% is reflected, 15% is absorbed. Let's suppose this grassy area, this marshy area, let's suppose it has an albedo of 0.2 or 0.15 is generally the albedo in these cases. Let's assume 0.15. So that means 15% is reflected, 85% is absorbed. Now, how does that lead to the variation in temperature? So for that, let us consider a couple of instances. And it is a very straightforward concept, very simple one. Depending upon the reflective nature of the surface or the reflective coefficient of the surface, you will have greater amount of reflection and lesser amount of absorption, or vice versa, can also be possible. Now, in the first instance, let's suppose this body has an albedo of 0.8, let's suppose. And here this has got an albedo of 0.3, let's suppose. Okay. Now here, as the solar rays come in, 80% will be reflected back. 20% is absorbed. Right? Whereas in this case, you will observe only 30% is reflected back. 70% is absorbed. Isn't it? Now, greater the amount of heat which is absorbed means the temperature will rise up. Isn't it? When you have greater amount of heat which is absorbed by a surface, it will indicate a higher temperature. A region which is absorbing very less amount of heat, lower temperature. So, more heat that is absorbed, more heat when absorbed. Here, instead of heat, you can also talk about more solar insolation. When absorbed, leads to higher temperature. This is the reason why when you talk about the snow-covered peaks and mountains, they receive very high amount of solar insolation, but that does not heat them to the same proportion as maybe a rocky region here. If it is exposed, it will get heated quite substantially. That is why, because in these ice covered areas the amount of reflected heat is so very high. Again, when you happen to venture into those snow covered territories or the ice covered regions, you necessarily need to protect your eyes also, because the solar glare is so very high. Those of you who would have witnessed snowfall and regular snowfall, for example, in the region of Jammu Kashmir, for example, in the region of Sikkim and some parts of Arunachal in India, we experience snowfall only in these areas, and also some parts of obviously Himachal and other areas of Uttarakhand. Now, in those areas, you would observe that if you don't cover your eyes, if you don't protect your eyes, you get a very, very debilitating headache for that matter after some time, because you are exposed to very high intensity of those reflected rays from the surface. The rays, they fall upon the surface and they get reflected back. So that is a phenomena that contributes to the variation in temperature in different areas. Okay. Ladakh also, you will experience that. Even in Jammu Kashmir, you do experience. In Jammu Kashmir, along the Zaskar and the Pir Panjal ranges, you will experience that. If we put tiles on the roof, will it absorb or reflect solar rays? Depends. Depends what kind of tiles that you put. That is why always it is said, or if you would have observed that in, for example, Rajasthan. Rajasthan is a region where the heat experience is generally very high. Observe the traditional settlements in Rajasthan. They would always paint their houses in a bright color, and that is to reflect back that heat, right? And in cases, in majority of our households, you would observe, and especially in the single individual units of houses that you have, the roof is basically tarred. You tar the roof in order to provide that waterproofing, and during the summer it gets extraordinarily heated up. Why? Because that black color absorbs all the heat. That is why always advisable to have the whitish appearance. Taj Mahal is the best example. Yes, Ziba, that is correct. Right. So that is basically the case of albedo. Now, this albedo is instrumental for the variation in temperature that we experience in our urban areas, and also in accelerating the melting of ice in the polar regions. So, when we talk about the role of albedo and the polar ice melting, especially in the region of Arctic, that is very common. And nowadays, even around Antarctica, this is becoming a common phenomena. But Arctic, I hope we have this much amount of idea that Arctic is an ocean. Arctic, when we talk about the region of Arctic, it is not a continental land. All that ice is on top of water. Whereas the region of Antarctica is all that ice on top of landmass. So there is a major difference. When we talk about the region of Arctic, it doesn't have that thick an ice deposit as compared to Antarctica. Antarctica, in many areas, has a uh, ice deposit thickness of 2 kilometers, 3 kilometers, or more. That is not the case in Arctic. Now, due to various events across the planet, the region of Arctic is experiencing warming at a higher rate due to the air circulation patterns, etc. The region of Arctic is warming up almost twice the rate as compared to rest of the planet Earth. This is leading to melting. But then also the fact that melting is happening in the Arctic is also responsible for rise in temperature. How is it possible? So it is a kind of a feedback loop system which is established. Let us understand that. So due to warmer temperature, due to warmer temperature, Arctic ice melts and thins out. Right? So when you have melting ice, now that will lead to, when let's suppose the ice melts, so water will be exposed. Now, if you look at the property of water and if you look at the property of ice, which will reflect more? Obviously, ice will reflect more, water will reflect very less, water will absorb more. Water has got an albedo again between 0.2 to 0.3. That means almost around 70 to 80% of the solar rays are absorbed by water. So here, as the ice melts, water is exposed. When water is exposed, means greater absorption of solar rays, greater absorption of solar rays, isn't it? Due to lower albedo, low albedo. So here, when you have a greater absorption of solar rays, then what does that lead to? Greater heat which is retained, greater heat attained. And what does that lead to? Further thinning of ice, which means thinner ice. I hope you would have observed even in the freezers of your refrigerator, thick ice, white in color, thinner ice, almost transparent in appearance. So, thinner ice will reflect less, absorb more. Thicker ice, like whitish in appearance, will reflect more. So, when you have thinning of ice, that leads to, again, greater absorption. And that greater absorption will further lead to the melting of ice. So this cycle continues to happen. That is why the region of Arctic is melting at such an extraordinary rate, where it melts almost immediately. So that is what you observe in the case of Arctic area and the polar regions also. This is also one of the reasons, the albedo is also one of the reasons why even in Himalayas, the glaciers, their rate of melting has accelerated. And why has that happened? So basically, in the Great Himalayas and even in the Middle Himalayas, you have many of the snow covered peaks, many of the glaciers which are present. But in the northern part of the country, the population density is very high, right? Right from the region of Punjab all the way till the region of Assam. The population density is significantly higher, and these are the polluting regions. Pollution is one of the mainstays or the key themes of current affairs right now that you would be coming across. Now, during that pollution, when you, let's suppose, burn stubble out there in the field, or let's suppose you are driving a very old vehicle out there, vehicles which are suitable to be placed in museums, not on roads. So many of the people ride those vehicles. So they emit that black smoke, right? And in that black smoke, you have very small particles of carbon, which is lesser than in the size or even around the size of 2.5 microns. That is how small the size is. So that black carbon that starts getting emanated into the air. And these black carbon deposits, they are happening over the region of the Himalayas. Now, the Himalayas covered under ice would ideally reflect all the solar rays. But now that you have the black carbon deposit happening on them, that has, in a way, reduced the albedo. And when we say reduce the albedo, means lesser reflection, more absorption of solar rays. And when you have lesser reflection, more absorption of solar rays, means what? Melting. Melting means the ice becomes thinner. Means what? More absorption as compared to the thicker ice. Means what? Further melting. So that is how a chain reaction is being set in motion in the region of Himalayas. So this is one of the other reasons why we need to tackle pollution, especially in the northwestern part of the country, as urgently as possible. When we talk about stubble burning and other factors which are happening in Punjab, that needs to be brought to an urgent and immediate halt. Otherwise, the glaciers originating from the Himalayas, which feed all the varying rivers, which crores of people have their lives dependent upon, everything can become a thing of the past. So that is why we need to tackle that pollution. Otherwise, the Himalayas are also melting at an accelerated pace. Okay? Now, here we have to understand that when solar rays are received on the ground surface, basically land and water, they get heated to different proportion. We'll talk about that, but before that I want to introduce you to the concept of an urban heat island, which is also dependent on the factor of albedo. What do we understand by an urban heat island? So again, I want you to recollect from your lived experience. You would have experienced that when you visit your native place or a village or a rural area or in the region of a forest, the temperature is pleasant, it is cooler. But you enter into the heart of the city, the temperature immediately rises up. It becomes very, very hot, isn't it? So, in the urban landscape, you experience a very high amount of temperature. As you move away from that urban landscape into the suburbs, into the small residences, towns, and eventually rural areas, it becomes cooler and cooler. But within the urban landscape, as you can observe by this particular graph of temperature, that the temperature keeps on increasing and again reduces in the vicinity. This is a factor which is referred to as urban heat island. Why island? Because when we talk about an island, it is a land in midst of water body, right? An aberration in the midst of a uniformity. Similarly, here also, heat is restricted in the urban areas. All around it, it is colder. Be it Mumbai, Delhi, Kolkata, Bangalore, Hyderabad, and earlier Chennai was basically not the case, but now even Chennai. So you will observe that in the urban areas, there's a spike in temperature. And why does that happen? Because of the factors of albedo, etc. So that is the urban heat island, is that part of an urban or a metropolitan area that is marked by remarkably high temperature as compared to its rural counterpart. So there are certain reasons why the urban areas they experience a higher amount of temperature. One of the reason is darker surface in the form of the asphalt on the roads. Asphalt, I hope uh, we have heard this term before, where when you would have read about the fractional distillation of crude oil, or basically leave that, when you would have heard about the tarring of the roads, etc., which is carried out, that is asphalt. It is also the layer which covers sometimes your roofs in order to provide waterproofing. So all these are darker in appearances. Majority of the roads out there, they will be very darker in appearance, dark bluish to blackish in appearance, and they will be absorbing the heat. Now in the urban landscape, the concentration of these areas will be very high, so there will be a lot of heat which will be received, lot of heat which will be trapped, right? Now here also in the urban landscape, if you consider the urban landscape, you have buildings in very close vicinity. Buildings in very, very close vicinity. Now, when you have such type of a construction, be it of residential properties or be it of the office spaces, where all the buildings are placed very close to each other, there is no movement of air or wind which is allowed, right? Generally, what you experience during the even the hottest of the summer months, recall it from your memory itself. You would have experienced that even though it might be very, very hot, but if the wind blows, suddenly there's a lot of relief, isn't it? It provides that moderation. Here, because of the construction, because of the congregated construction, all that construction concentrated in the urban areas, the wind pattern does not exist. So there is nothing to dissipate the heat. So the heat keeps on mounting up. So here, there is lesser heat dissipation because of less movement of wind because of construction factors. Then lack of green cover leading to less cooling. In the urban areas, you have very less green cover, right? Green cover, wherever it is, it provides shades also. It provides that level of cooling. Okay. And eventually, we will study that green cover is also responsible for bringing some amount of rainfall in the area, again, brings about some amount of cooling. But when we talk about plants in general, the plants, they tend to lose water into the atmosphere by a process which is referred to as transpiration. You would have heard about transpiration. So transpiration basically is where the leaves have certain pores, and through those pores they lose water into the atmosphere. That is transpiration. So even during this phase, whenever evaporation or transpiration happens, it leads to cooling. Evaporation is one of the factors which leads to cooling. That is why when you are all sweaty and when you perspire, all perspiration has happened throughout, let's suppose, when you ventured outside your home during the day, you come and sit inside your room and you sit underneath a fan, you feel cooler. Why do you think that is the case? Is it because the fan is emitting colder air? That is why you feel cooler? No. The fan is simply circulating the air. And as the air circulates, the sweat evaporates, and evaporation provides that cooling. So when you have lesser plant cover, there is lesser or a very limited scope of evaporation or transpiration also happening. That means an accumulation of heat, right? So that is lesser cooling. Then lack of open soil regions, I'll come to it. But before that, greater greenhouse gas emission. In the urban areas, pollution is very high. More amount of transportation, industries, etc. They will release a lot of greenhouse gases such as carbon monoxide, carbon dioxide, sulfur hexafluoride, methane, water vapor. All of that is released. Now, all that leads to accumulated sense of warming, accumulated amount of warming and heating. Whereas in the rural landscape, in the semi-urban areas, you don't come across these realities, do you? So that is why here that leads to greater heating. Greater heating. Okay. Then in the urban areas also, when we talk about the office spaces or residential buildings also, you have a continuous operationalization of the air conditioners, of electrical lines, of let's suppose energy requirement is so very high during the day also, and during even the winter months many of the office spaces need to run the air conditioners because inside it is so very hot. Now when you run and operate an air conditioner, while it might cool the inside of a room, but on the outside, it emits warmer or hotter air. So on the outside, it heats up the region. On the inside, it might cool that area, but on the outside, it heats up the region. So that is why even greater energy utilization and utilization of air conditioners, etc., that also substantially increases the outside temperature. Then we come to the lack of open soil regions. What do we mean by this and what is the relevance of this? So, in the urban areas, generally you will encounter, not so much in our urban areas, but when you think about the urban areas such as the New Yorks of this world, the Singapore of this world, the Hong Kong region, and for example, Tokyo, the major urban cities, London, etc. When you think about these urban areas, in our cases, we have not developed the urban landscape to such an extent, but you have the examples of Shanghai's and New York's and Chicago's and Seattle's of the world. So here, understand this. Let's suppose there is rainfall. Rainfall is received. Now, in the rural areas or in the semi-urban areas, what happens? There is soil, right? So all that rainwater falls on the soil. Now, the next day or after some time, that water evaporates back from the soil, isn't it? So, as it evaporates back from the soil, maybe next day early morning or maybe next afternoon, whenever it happens, evaporation is happening, leading to some cooling down effect. Whereas in urban landscape, what happens? Rainfall is happening, all that rainwater immediately diverted to the region of the sewers, manholes, etc. All that water is diverted there. So there is no such latent evaporation or an evaporation which happens eventually, which will cool down that area, isn't it? So that is why always advisable that urban landscape should have certain green patches, open green patches, without any buildings or whatever, so that even that rainwater can evaporate. Cooling can be provided. That is why green spacing is a must for any urban morphology, for any urban development and urban planning. If you remove the green space, you are virtually strangling the city to its death. Okay, so that is the reason why the urban landscapes experience very high temperature. Now, what can be its cure? What can be the remedy? Generally, whenever you are in a position to explain the reasons for a problem, you will be in a position to talk about the solutions also. So, what are the solutions? Have more reflective construction, reflective buildings, right? So, buildings with a certain amount of glass panel which is reflective in nature. Install solar panels in many areas so as to generate that electricity without the utilization or without the emission of greenhouse gases. Ensure that the spacing is such that wind pattern is in existence, wind movement is in existence. Devise the establishment and green buildings. And green buildings, by the way, does not mean a building which is green in color or a building which has a lot of vegetation in it. Right? Many of you have the misconception that green building means a lot of vegetation in that building. On the roof also will have a good garden, etc. No, green buildings mean which are energy efficient, right? Where during even the warmest and the hottest of the day, you have the flow of air, and even during the daytime or the afternoon, you don't need to switch on the lights in the building because you have natural light which is coming in. So such buildings need to be incorporated, and understand such architecture is being developed across the world. It is being established, it is being developed, and everything is there in nature in front of us to gain an inspiration. For example, when very briefly I will digress to that point of architecture, that when we talk about ant hills, the ant hills that you would have observed where colonies of ants live together, you would have seen on the sides of the roads, you have these ant hill like structures which are there. Now, they are mostly, they are basically constructed by the ants without any shade out in the sun. It has been found out that the temperature inside the ant hill is much cooler as compared to the outside. Why is it so? It is because the ant hill has got so many perforations. It provides that channel of air to flow, which lowers the temperature. So that if the ants can devise a structure like that, we humans can definitely do so. So that is being talked about as the inspiration for the next generation of green buildings being designed. But as this happens, you need to tackle the urban heat island problem, because across the world, I'm not talking about ant hill, I'm talking about ant hill. Okay. So this is just an example I am giving you. So as the rate of urbanization across the world is increasing, more people are going to live in the urban areas. They are going to experience increased events and instances of heat strokes. So, urban heat island as a problem need to be tackled. How do we tackle that? Green buildings, better architecture, better green spaces, availability of open areas. That is the solution. Okay, so that is where we'll take a break now, right? And Bangalore is always cool. Bangalore, Shabir, is cool because of a gap which is present in the Western Ghats, which allows for the movement of the winds. It is the same reason. Obviously, now you won't be able to gather it very clearly, but just to give you an idea, it is the same reason why Pune is cooler. It is the same reason why Nashik is also cooler as compared to the surrounding regions. It is because of the flow of the wind. What could be the type of mains question from this portion? In fact, from this area, you had a direct mains question. You had a question which was asked in the optional, also in the general studies also, that what is the concept of urban heat island? Why does it happen? And what are the measures, remedial measures? Right, Rajneesh. Sandeep, if all the ice melts, is there any possibility of flood? In the immediate future, yes. In the long term future, no. So now we take a break, and after that, we come back. And before that, Ritu, I will answer your question that you said that green areas absorb more heat. as compared to the ice covered region, not as compared to the concrete buildings and the concrete roads. They absorb much greater amount of heat. When I said that the green areas of the forest regions, they absorb more heat as compared to ice covered areas. Okay, it is in comparison. But also understand, by providing that shade, by allowing that evapotranspiration to happen, they cool the area also. They absorb heat, but they cool the region also, because of the property of the trees and the property of that green foliage. Okay. Now we take a break and we'll be back in 10 minutes, right? I think 10 minutes break will work for today, right? So let's take a 10 minutes break and let's be back in 10 minutes. 15. Okay. Take 15. But this will be the last week I'm giving 15 minutes break. Let me announce it now itself. From next week, you will get 10 minutes break only, regardless of how many please and otherwise I'll die. I need to have breakfast. I need to visit my friends. Regardless of the excuses, from next week onwards, it will be a 10 minutes break. Let's go for a break and let's be back. A confirmation about the audio, please. If the audio is clear and available. Thank you. So now we come to another basic portion, which eventually, as we will find out, is going to be one of the major reasons why wind patterns exist in a certain manner, why different areas experience different weather conditions, and that is the difference of heating when it comes to land and water. So let us try to understand that what is the difference? Because on the surface, both of them will receive equal amount of solar insolation. But the pattern of heating and the pattern of cooling down, that is quite varied. So here, let's suppose we consider a land area and a water body. And again, from here on onwards, whenever we shall be referring to a water body, we shall be referring to an ocean or a sea for that matter. Okay. We are not going to refer to a water body, a pond in my backyard. I have seen a larger river near my city, so that is where can we consider them as a large water body? No, we are talking about seas and oceans. Now here, when we talk about the solar rays will fall here also. The solar rays of insolation or the solar insolation will fall here also. But then the impact will be different in the sense that when we talk about the land areas, now all that heat or all the solar insolation, will that be penetrating the land and reaching the deeper levels of the crust? No. All the solar rays which fall upon the ground surface, they are restricted to around 2 to 3 inches of thickness itself. Beyond that, they don't have any impact, right? So all those solar rays will be restricted very, very close to the surface at max to a depth of 3 to 5 inches, right? Restricted to the surface. But when we talk about a water body, like a sea or an ocean, now they are transparent in nature, water is transparent in nature. So this solar energy or these solar rays which will be received, now that will be dissipated in the water, that will be distributed in the water also. On top of that, water has got its movement. Water will not remain static in one area. Water will continue to move from one region to another and vice versa also. So when we talk about the attainment of heat or the variation in temperature, in the case of the water body, that same heat is distributed all around, right? Whereas in the land area, it is restricted and concentrated in the same region. So, which will exhibit a higher rise in temperature or a faster rise in temperature? Will it be a water body or will it be the land area? Which will indicate a faster rise in temperature? Always the land area? Perfect. Always it will be the case of the land area. Why? Because all that heat is restricted to 3 to 5 inches of the land, whereas the water body it gets dissipated. So the time taken for the rise of temperature in water body is much longer because it will heat this portion also, this portion also, this portion also. So that heat will be dissipated. So the basic fundamental, land gains heat much quicker as compared to water. Now, during night time, when you don't have that heat to be received, during night time, you heat will be lost from the surface, be it the water, be it the land area, heat will be lost. Now, when I talk about the night time, here you have to understand that for the land, it means losing all the heat which is accumulated in this thin portion. So during night, that loss of heat will happen from the land area also. But when it comes to the water body, the heat gained in all the portions of the water will be lost. So it will be a slow process, isn't it? So that means land loses heat at a faster pace because all that heat was concentrated only on the surface. But whereas water, eventually it might have managed to heat up during the entirety of the day. But then when water needs to lose heat, it needs to lose heat from the interior also, isn't it? Is there any doubt in this? This is a simple concept. Okay, what is the portion which is not understood in this particular portion? Which is the portion which is confusing you out there? Do let me know. Otherwise, how will I address it? Whole. Can we start directly from insulation again? Should we start from insulation, the entire process of it? Okay. Listen to this very carefully. When I say this, listen to things carefully. I'm going to repeat it again. So when we talk about the surface will consist of both land areas as well as water bodies. Now, during the daytime, solar rays will be received by both the land areas as well as the water bodies. But when the solar insolation or the solar energy hits the land area, it will be restricted only to the surface. When we talk about the rocky regions, when we talk about the sand surfaces, it is not as if the solar rays will penetrate 10 centimeter below the ground surface or the solar insolation will penetrate 15 centimeter below the ground surface. So all that solar rays will be restricted only to the surface. Whereas when we talk about the water body, such as a larger sea or an ocean, when the solar rays they fall upon that water body, will that be restricted only to the surface? No, water is transparent. So all that heat will be dissipated into various different depths of water. So basically, the time taken for land to heat up, to increase the temperature by 1 degree Celsius will be much shorter. Land will get heated up much quickly because all that heat is restricted only to the surface, all that heat is concentrated only to the surface. Whereas when we talk about the water body, the heat is distributed inside, right? So in order to indicate 1 degree Celsius temperature rise, water will take a longer period of time because not only the distribution of heat, the water is not static. The land is static in a place. It is not the case that today the rocks in the morning are here, by evening the rocks will move somewhere else. No, the land is static. Whereas when we talk about the water body, you have the ocean currents, the wave action, etc., the tidal motion, etc. So that brings about a movement in water body. So that means that heat not only gets dissipated in the water body, due to circulations, etc., it becomes much more difficult for the water body to attain heat. So that brings us to the first conclusion that land gains heat much quicker as compared to the water body. Now, when we talk about the night time, during the night, the regions they lose heat, right? During the day, they gain heat, during the night, they lose heat. Now, both land and water have to lose heat. All the surfaces, they lose heat during the night time. In case even that basic is not something which is comprehensible, all the surfaces, regardless of land, water body, mountain, plain, valleys, plateaus, everything, during night time they lose heat, during daytime they gain heat. So during night time, the land area will also have to lose heat, the water body will also have to lose heat. When we talk about the land area, it has gained the heat throughout the day, but all that heat is restricted only to the surface, isn't it? But when we talk about a water body, it might happen that by the evenings, etc., they would have gained some temperature, but that would be distributed homogeneously, almost homogeneously in the water. So when it comes to the time of the night, when the loss of heat has to happen, so because all the heat is restricted to the surface in the land, it will lose heat very quickly. Whereas in the water body, because the heat has been distributed, the loss of heat is a time taking process. So that brings us to the second conclusion, and that is land loses heat much quicker. Saurabh, if I start mentioning terms such as specific heat, I can only imagine the panic that will be created. So that is why I always prefer to stay away from any of these kind of mentions. Okay, so compared to water, any of the scientific terminologies is something that I will never mention, because immediately everybody starts, even if they can understand it, but the moment that they realize that it is a scientific concept, it creates a lot of panic. So if you know the specific heat concept, fair enough. Otherwise, now here, when we talk about the fact that the land gains heat much quicker and land loses heat at a much quicker rate also, so that brings us to a certain set of conclusions. During the day, for example, the land will gain heat much quicker. During the night also, land will lose heat much quicker. So that brings about a variation in temperature. So during the day, obviously, land is much hotter as compared to water body. Land is much more hotter as compared to water body during the day, because it gains heat very quickly. Whereas during the night, the land will take some time to land will basically lose heat very quickly during the night, because all that heat is concentrated on the surface. Water takes a larger amount of time to lose heat. So that is why during the night, land will be colder. Land is much colder in comparison to water body. Right? So in the case of water body, because water is basically transparent, that heat is allowed to penetrate through the surface, that heat of the sun. So even if you are, let's suppose, 100 meters below the water surface, even there you will receive solar rays. If you are 200 meters below water surface, there also you will receive solar rays. Right? It might have different amount of heating or cooling, but you will receive. But when we talk about the land areas, even if you go 15 centimeter below, you won't receive that heat. Maybe the heat from what you have mentioned as conduction, some heat will be percolated, but that's it. It won't penetrate furthermore. Whereas in water body, it will penetrate quite significantly. Then, when it comes to the conditions of summer and winter. During summer. Now, during the summer season, you have on an average 4 to 5 months of high heat which is gained because the daytime is longer, the nighttime is shorter. So during the summer months, you have a longer average where heat has been received in surplus. Now, when the heat is received on surplus, in surplus quantities for that duration, what do you experience? The land areas, they will get much hotter as compared to water body. So here, land areas become much hotter as compared to water. Now, what about the winter season? When we talk about the winter season, so during the winter season, for a cumulative 3 to 4 months duration, there is a loss of heat because night times are longer and daytime is shorter. So, on an average, the region loses its heat. That is why the regions become colder. Now, during the winter season, it is about loss of heat. So, which will lose heat very quickly? It is the water body which will lose heat very quickly. That is why, oh, it is the land areas which will lose heat very quickly. Water bodies take some time to lose that heat. So, that is why when we talk about it, land areas become much colder as compared to water. So that is why during winter season, you will find that the oceans and the seas are comparatively warmer than the landmass. During the summer season, oceans and seas, they are comparatively cooler as compared to the landmass. So that is because of the variation in the rate of heating and cooling which is received. And it all stems from the very simple, basic, fundamental. All the heat received on the land is restricted on the land surface at max a depth of 3 to 5 inches is disturbed by that heat. That is why, if you remember, during your childhood days when you would dig holes in the ground, obviously you won't use an excavator, you would use hand tools, etc. And when you would reach the soil of slightly greater depth, maybe a couple of feet, you would have found that the soil would have been colder in comparison to the soil on the surface. I'm sure you would have experienced that, or you would have played with that soil in your childhood days. Whereas you go to the lower regions, maybe 5 centimeter or 10 centimeter, 20 centimeter, if you dig the soil, it will be colder, right? Why? Because the heat is restricted to the surface. When we talk about the water body, that heat basically is transmitted through the entirety of the body, so it takes more amount of time for the water to gain a temperature. This can also be simplified in a simple sentence if you understand the concept of specific heat. Water has got a higher specific heat, so water takes a larger amount of energy to show or indicate an increase of 1 degree Celsius of temperature, whereas the land areas, they will indicate an increase of 1 degree Celsius at lesser amount of heat also. Nonetheless, that brings us to the main portion that during the summer months, it is the land area which is warmer. During the winter months, it is the water bodies which are comparatively warmer. Okay. Now, after this, when we come to the distribution of temperature or the variation in temperature in different areas. So, as I told you earlier also, that temperature is dependent on a variety of factors. Insolation is just one of those factors which influences temperature of a region. Any area, depending upon its location, depending upon distribution of land and water, existing wind patterns, etc., there is a significant variation in temperature which is experienced. So let us take a look at the factors which will end up influencing the variation in temperature. First is the latitudinal position of a region. Now, how does that impact it? So, we have already seen that the lower latitudes, they receive direct rays of the sun. Whereas when we come to the higher latitude, they receive a kind of a slanting rays of the sun or an inclined ray of the sun. Obviously, greater energy is received when the solar rays are direct. So that means a greater amount of heating, right? So here, lower latitudes get direct rays of the sun, and hence greater heat. Whereas higher latitudes receive slanting rays and hence are colder. That is why, by the time that you reach the region of the poles, you are already experiencing a temperature close to minus 20, minus 30 degrees Celsius. Whereas around equator, you have the direct rays of the sun for majority of the part of the year. So you experience a higher temperature range. So that is one of the major factors. Then comes the altitude of the place, the location, or what is the height of any particular region. Now, we do know with the increase in altitude, despite the fact that the amount of solar insolation is higher, the temperature reduces. Right? Why? Because as we move higher up in altitude, the density of gases reduce. The density of water vapor, various different gases, all that starts to reduce. So when that density reduces, means what? There is lesser number of particles to trap the heat which will be released by the surface. So when the surface tends to lose heat from an altitude, the heat will be lost very easily. Whereas from the ground surface, that heat will be retained. Why? Because you have so many particles closer to the ground surface, they will retain heat. Right? So here, with a greater height, with a greater height, the number of atmospheric particles reduce. Payal, please ensure you ask this question at the end of the class when we will be taking up the questions. I will address that question. The number of atmospheric particles are very less. Hence, no or not much retention of heat is observed. Right? So heat is lost very quickly at an altitude. So that is why the excuse me, that is the reason why the top of mountains, etc., despite receiving very high amount of insolation, they become very cold during the night time or during the evening time. When the heat received that stops, immediately that region will start losing heat, and within a few moments that heat will be lost so very quickly, it will become very, very cold. So that is why we experience a kind of a normal lapse rate or the environmental lapse rate that we studied with, where on an average, with a rise of 1 kilometer in height, the temperature reduces by almost 6.5 degrees Celsius. Now, then you have other factors also which influence the temperature. One of the factor is distance from the sea. Now, when you have a region which is closer to the sea, there the temperature conditions are almost consistent throughout the year. And when you compare it to a region, let's suppose like Delhi, Chandigarh, Ambala, which are very far away from the sea, there the temperature conditions are much more extreme. So what is the reason for that? So there are a couple of reasons for that. First reason is in the coastal areas, in the coastal regions, the amount of water vapor present in the atmosphere will be very high. Humidity in the atmosphere will be very high. So they will retain greater amount of heat. So they won't allow significant variation in terms of temperature, because we have studied earlier also, yesterday also, when you have more water vapor, they will retain heat. They will tend to retain heat. So here in the coastal regions, greater amount of vapor or humidity means retention of heat. Retention of heat, and hence maintenance of temperature in the coastal areas. That is why if you go to Mumbai, if you go to Goa, if you go to Chennai, if you go to Vishakhapatnam, you will observe that the seasonal variation is also not very high. If the summer season is 34 degrees Celsius, winter season will be 25 degrees Celsius, not much, right? Consistency of temperature even during day and night is observed. Why? Water vapor facilitates that, humidity facilitates that. Another reason for that is basically in the coastal areas, you have the movement of wind, strong movement of wind in the form of land breeze and sea breeze. Now, that land breeze and breeze provide some amount of relief and does not allow the temperature to go to the extremes. As the land gets significantly heated up, a colder wind from the sea will come through. As the land starts becoming colder, a wind from the land will go to the sea. So this will never allow the temperature to reach the extremities. Whereas when you talk about the regions in the interior, for example, Hyderabad, for example, Nagpur, for example, let's suppose Bhopal, for example, Delhi, you don't have such interventions. That is why in those areas you will find that the summer temperature is 48, winter temperature is 2 degrees Celsius. That is why they always experience extremities of temperature, whereas the coastal areas, they never experience extremities of temperature. Okay, so presence of land and sea breeze. We will study land and sea breeze separately in the next module also. Ensures maintenance of temperature and doesn't allow extreme temperatures to exist. Which is the case in the interior areas, the areas which are also referred to as continental regions, because they are surrounded by land from all sides. That is why many of these areas are also referred to as continental regions. Then you have the role of the prevailing winds. Prevailing winds means what? The existing wind pattern in any particular area. We will study about the permanent wind systems in the next module also. So prevailing winds, they refer to existing wind patterns. Existing wind patterns in any region. So we do know that wind, depending upon whether it is cold wind or whether it is a hot or a warm wind, that also tends to influence the temperature, isn't it? So we do know that even when we talk about the wind movement, it is of two types: cold advection and warm advection. Warm advection. When we talk about the cold advection, increases the temperature or decreases the temperature in an area? The temperature in an area. When we talk about warm advection, it tends to increase the temperature in an area. Okay, so that is the role that the winds also have to play, and they get to play that role. Then you have other factor which also influences the temperature, that is the ocean current. Ocean current in detail we will cover in the portion of oceanography, that what they are, why do they exist, where they exist, what are the classifications, all that we will cover in detail later on. But here just to give you a brief about it, so in the oceanic water also, in the region of the oceans also, you have movement of water from one region to another based upon many different factors. You have movement of water in certain pathway in a definite direction, where large volumes of water are carried from one portion of the planet to the other. Now this ocean current also has a variation in temperature. For example, when you have oceanic water coming from higher latitude to lower latitude, that is from the polar region to the equatorial region, they will bring colder waters. When you have ocean currents coming from equatorial region to the polar region, they will bring warmer waters. So that bringing of cold or warm water also brings about a moderation in temperature, or brings about a variation in temperature. For example, here in this image, you see the ocean current, some of them with blue, some of them painted red. Red indicates a warm ocean current. So here you observe that you have a North Atlantic drift here, this one. Now, this North Atlantic drift is a warm ocean current. Now, that increases the temperature in the northern portion of Europe and ensures that many of the ports in these areas, they remain ice free through the year, ensuring trade navigation activities. Otherwise, at these latitudes, many of these regions would have been completely frozen. Okay, so example, presence of North Atlantic drift. Atlantic drift, which is actually a warm current. Okay, that North Atlantic drift ensures the water in Northern Atlantic, remain ice-free, ice-free for most of the year. Okay, so in brief, again, what do we mean by ocean currents? So ocean currents are basically streams of water in the ocean itself. You have streams of water. It appears as if these are rivers of movement in the ocean, because they move in a certain set direction in a certain specific pathway across the entirety of the planet. And based upon their variation in temperature, let's suppose oceanic water is carried from this portion to the north here. Let's suppose it is being carried away from this portion all the way till here. So this warmer water is brought here, increasing the temperature in the higher latitude also. For example, you have colder water being brought from here all the way till here. So this will lead to reduction in temperature in these areas. You have the cold California current, which will reduce the temperature of the western coast of US. Here you have the cold Peru current, which will lower the temperature of the western coast of South America. Like that, the variation in ocean currents have their own role to play in impacting the temperature. Now, then we come to the concept of isotherms. What do we mean by isotherms? Iso means similar, therm meaning something to do with temperature. So isotherms are basically imaginary lines joining places having equal temperature. So for example, this is an image of an isothermal representation of temperature across the world in the month of January. So for example, here you observe a 10 degree C isotherm. It invariably will be joining all the places which are experiencing 10 degrees C at that particular point of time. You have a 0 degree C isotherm, invariably joining all the places which are representing 0 degrees Celsius at that point of time. So when we talk about isotherms, isotherms basically are imaginary lines joining places of equal temperature. So let's suppose I have different places A, B, C, D, and E. Let's suppose this is 40 degrees. Let's suppose this is 40 degrees. Let's suppose this is 38 degrees. This is again 40 degrees Celsius. This is again 40 degrees Celsius. So the 40 degree isotherm will be drawn somewhat like this, joining all the places indicating 40 degree at that point of time. So this is also referred to as 40 degrees Celsius isotherm. So invariably, it will be passing through only those places which are experiencing 40 degrees Celsius. Or we can also look at it from a different perspective, that when we see a 40 degrees Celsius isotherm, we can come to a conclusion that all the places lying on this isotherm, they are going to experience a temperature of 40 degrees Celsius. So that is the conclusion that we can gather from here. Okay. Now, why are isotherms used? Isotherms are used to depict the variation in temperature across the world from one day to another, from one month to another, from one season to another, and from one year to another. So that variation in temperature, if you have to show that how the temperature distribution is there across the world, how will you depict it? You will depict it with the help of the isotherm. So that is where the isotherms, they are of incredible amount of use. So that is what do we mean by isotherms. Now, here is a representative image of the isothermal, or in a way, isothermal representation during the month of January. Now, during the month of January, we have winter in the northern hemisphere, summer in the southern hemisphere. Now, based upon that, let us observe this image and let us have some findings of our own. So, first of all, when you take a look at this image, you will find temperature mentioned on the sides. Now, these temperatures indicate the isotherm which exists. So, observe the isotherms in the northern hemisphere, the general trend of it. And when you observe the isotherms in the southern hemisphere, you will observe that the isotherms of the southern hemisphere, they are almost parallel to each other. The isotherms of the southern hemisphere, they are almost parallel to each other. And why is that the case? You don't find that situation in the northern hemisphere, but in southern hemisphere the isotherms are parallel. That is because southern hemisphere is dominated by water body, dominated by oceans and seas. And we do know that in oceans and seas, or the water body, temperature variation is not immediate. Temperature varies uniformly, very homogeneously, slowly and steadily. That is why the variation in with latitude, the variation of temperature with latitude is mostly the variation that you experience. That is why mostly the isotherms are parallel to each other. Whereas when you observe the northern hemisphere, you will observe all sort of various different variations because of a larger concentration of land mass followed by water bodies. Now here, let us basically summarize what we had studied earlier about the temperature difference between land and water, where we observed during the winter months, which will be colder, land areas will be colder. During the summer months, water bodies will be colder. So when we are talking about January, we are talking about winter in the northern hemisphere. Let us observe that at the same latitude, is there a variation of temperature or not? So if I have to draw an image, or draw a diagram Let's suppose here. Let's suppose this is the latitude that I will consider. Now let's demarcate few of the places. A, B, right? C, D. Now temperature at A. What will be the temperature at A? Based upon the isothermal analysis. Very good. It will be minus 12.5 degrees Celsius, isn't it? Minus 12.5 degrees Celsius, because A lies on that particular isotherm. This is the isotherm on which A lies, and this is a minus 12.5 degree isotherm. What is the temperature at B? 0 degrees Celsius. So at the same latitude in very close areas, what do you observe? You will observe that A is much colder, land is much colder, whereas the water is comparatively warmer, right? So that is why you will experience that generally the isotherms, when they are present, isotherms represent the temperature, right? A unified temperature. Now, if I consider any isotherm here, let's suppose I consider the 0 degree C isotherm. Now, this 0 degree isotherm, as soon as this represents 0 degrees Celsius all over this land area, but as soon as it comes to the water body, in order to experience 0 degree, isotherm has to move towards the poles, or the isotherm has to bend towards the poles, because 0 degree in water will be observed at much greater latitude, much higher latitude, whereas over land areas, they will be experienced even at lower latitude, isn't it? That is the reason why we say that when we talk about the portion of these isotherms, when they cross from land to water during the winter season, basically, when you take a look at their drawings or the representation, they always bend equatorward, right? So during winter months, the isotherms bend polewards as they move from land to water. As they move from land to water, they move polewards. They bend polewards because water at the same latitude will experience a much higher temperature. During summer condition, it is something to the opposite. Now, here I understand you see something known as the thermal equator. Now, thermal equator generally represents the absolute low pressure area or absolute most heated portion during that point of time in the lower latitude. So that is what thermal equator represents. So that is something we will cover when we come to the portion of ITCZ and the portion of the low pressure and high pressure. You will get an idea about that thermal equator also. Okay. Now, this is the representation that you can see of the various different conditions or the thermal representation during the month of January when it is winter in the northern hemisphere. Now, when it is winter in the northern hemisphere, observe here. The land areas, they are much colder, whereas the water bodies, they are warmer. Here you have that warm ocean current also, the North Atlantic drift that we talked about. That also further warms it up. But observe how the land areas, even to the lower latitude, they are much colder, whereas the water body is warmer. When we talk about the southern hemisphere, observe how the variation in temperature is almost indicated parallel to each other. That variation in temperature is almost indicated parallel to each other. And why is that the case? Because there is a dominance of water bodies, so there's a uniform distribution of temperature from one latitude to another. Then in the month of July, when you have summer in the northern hemisphere, so which will get more hotter? Land will get hotter, water will remain cooler. So observe here, the land is much hotter, water comparatively is cooler, isn't it? But in the southern hemisphere, it is still consistently parallel, indicating the large presence of water body, indicating uniform distribution of temperature. Okay. Now, that is about the distribution of temperature. Now, after this, we come to the concept of temperature inversion. But before we talk about the exact aspect of it, so what is temperature inversion? Just I will give you the briefing and then I will explain it to you. The reversal of the normal behavior of temperature in the troposphere is known as temperature inversion. So, what is the normal behavior of temperature? The normal behavior is that closer to the ground surface, you will have warmer air. As you move higher up, you encounter colder air, isn't it? The air temperature is highest near the ground surface, it is cold as you move higher up. But under certain conditions, due to certain processes, there is a reversal of this. So temperature inversion is where you observe the reversal of that. Why that happens, when that happens, all that factor will come to it. But before that, let me explain to you what this phenomena is. So when we talk about temperature inversion, at this point of time, Arctic region would be covered under darkness, would be experiencing nighttime, continuous nighttime. Now, under normal conditions, right? Under normal conditions, what we have is that closer to the ground surface, if let's suppose this is your ground surface, okay, if let's suppose you have this as the ground surface overall. Now here you have warm air and here you will have cold air. That is your positive lapse rate. Under normal conditions, you experience positive lapse rate. We have seen earlier also that colder air is heavier and will tend to have a sinking tendency, whereas warmer air being lighter will tend to rise up, isn't it? So that is where it leads to mixing of air, right? So it leads to vertical mixing of air. Leads to vertical mixing of air. But under certain conditions, especially during the winter months, you have a situation where closer to the ground surface, yeah, the ground surface becomes so very cold in certain instances. Okay, they will become so very, very cold that here the air closer to the ground will be colder and above it you will have warmer air. Now, warm air has a tendency to rise up, cold air has a tendency to sink. Here, cold air is already at the bottom, warm air is already at top. So, will there be a vertical mixing? Absolutely not. Right? So, there will be absolutely no vertical mixing which will be observed. So, this is the condition whenever it is achieved. That is referred to as the condition of temperature inversion. Of temperature inversion. It is achieved because of varying different factors. Not only one factor is responsible for this inversion of temperature, varying different factors are responsible why this happens. Okay, why this happens, we will come to it. But sometimes it does happen where at the base you have the colder air and at the top you have the warmer air. So that represents what? That represents a negative lapse rate. Okay. So that means no mixing of air. Right. So this is something that you experience during the winter months. And that is where, imagine, even if the pollution is caused, now that pollutant will stay in the atmosphere wherever it is. So the impact of pollution will be even further worsened if you have the condition of temperature inversion. So because here you don't have any vertical movement of air, so this is also what is referred to as a condition of stable air. Stable air does not mix. This is your unstable air. Unstable air, where the air tends to mix. So that is the condition of inversion of temperature. So here, now that I bring you back to the image, you will observe that under the normal conditions, you have warmer air at the bottom, cooler air at top. So the warmer air will have a tendency to rise up, colder air will have a tendency to sink. So there will be mixing. But under certain conditions, you have certain conditions. We'll talk about those conditions. Under certain conditions, you have a situation where the cooler air is at the bottom and the warmer air is at the top. So the cooler air cannot rise, warmer air cannot sink. So you have a stability of air condition, lack of mixing. The impact of events such as pollution, etc., gets much more exaggerated in the process. Now, when we talk about this inversion, this can be a very short time phenomena, that is during the nights, winter nights. It can be a long term phenomena of 15 to 18 days also. So this varies depending upon how does that happen. So based upon why does that happen, you have the classification into different types. You have the surface inversion, then you have the subsidence inversion, subsidence inversion, then you have the valley inversion, and then you also have the frontal inversion. So all of these, they depict the temperature inversion happening in different conditions and under different circumstances. So let us understand them. What do we mean by, for example, surface inversion, and why does that happen? When does that happen? So surface inversion, the name in itself tells you it has something got to do with the surface phenomena. So this is a kind of a temperature inversion experienced in even in countries like India, in the northern portion of India, there also you experience it during the winter nights. But during the in the region of middle to higher latitude, it is experienced throughout the winter season. In the polar areas, it is experienced almost throughout the year. So what happens? What actually happens? What is this condition of inversion? Understand that. So for example, suppose this is the ground surface. Let us consider two different situations and observe here carefully. It is a very simple concept. Let us understand, or let us assume, repeat surface inversion. I've just started surface inversion. What do I repeat here? So here, when we talk about, let's suppose the winter months, in the month of December or January. So let's suppose we are talking about the last of December. So in the last of December, the temperature of, let's suppose we are considering Delhi here, where late at night the temperature reduces to 2 degrees Celsius, 1.5 degrees Celsius, whereas during the day the temperature is 14, 18 degrees Celsius, isn't it? So let's assume the temperature that around 4 p.m. and the temperature at around 3 a.m. 3 a.m. when the surface would have lost all the as much heat as possible. By the way, When we talk about air, is air a good conductor of heat or is air an insulator of heat? What do you think? Does air allow the heat to travel very easily, or is air a kind of an insulator of heat? What do you think? Bad conductor, right? So air is not a good conductor of heat. Good conductor of heat, for example, metals, etc., they will allow the heat to pass through immediately. In the case of air, if one air parcel is heated, does not mean the next to it will also be heated. It might retain heat. So air is not a good conductor. It does not allow the immediate passage of heat. Now, here, let's suppose we are considering the ground surface. And at 4 p.m., the ground surface temperature, let's assume, is 15 degrees Celsius. Now, if the ground surface temperature is 15 degrees, and listen to this carefully. If the ground surface temperature is 15 degrees Celsius, there will be some air parcel in contact with the ground surface also. We have seen that by virtue of being in contact with the ground surface, the temperature of the air parcel is also impacted. So let's suppose this air parcel is in contact. Air in contact with ground. Here, what will be the temperature? Close to 14, 15 because it is in contact with the ground surface. So what is the temperature of ground surface? That will be reflected in the air temperature also, right? By the process of conduction, that heat transfer will take place. So let's assume that the temperature here also is 15 degrees Celsius. All of this I'm just assuming, giving you an example. Now, if I consider the air temperature at a particular altitude, at a particular height, maybe a couple of kilometers, maybe less, maybe more. Now, at a particular height, the temperature, let's assume, temperature is 8 degrees Celsius at this particular altitude. Okay. This is the condition at 4 p.m. Now, the night time falls in the winter season. The night becomes very cold, doesn't it? Nighttime temperature reduces quite significantly. Now, when during the night, the surface will lose heat by terrestrial radiation. The surface will lose all that heat by terrestrial radiation. Longer winter nights means more loss of heat. That is why during the winter months, when you have long winter nights, that is when the ground starts becoming colder and colder. We are talking about the month of December. So at 3 a.m., let's assume that the temperature of the ground reduces to 1 degree Celsius. Now, if the temperature of the ground has reduced or has dipped to 1 degree Celsius by 3 a.m., 4 a.m. in the night, the air in contact with the ground will also be impacted, won't it? This will also be impacted. So, air in contact will also have indicative 1 degree Celsius. Isn't it? They will also have an indicative 1 degree Celsius. But this air parcel has cooled down. Why? Why has this air parcel cooled down? This has cooled down because it is in contact with the ground surface and the ground surface has cooled down. If the ground surface was, when the ground surface was at 15 degrees Celsius, the air parcel also was at 15 degrees Celsius. Now that the ground surface is at 1 degree Celsius, the air in contact will also be at 1 degree Celsius because of the process of conduction. When materials of different temperature, they are in contact with each other, they exchange heat, right? But what about the elevation here? At this elevation, will the loss and gain of heat happen in the same proportion here? No, because air does not radiate or air does not transmit heat efficiently. So here, the temperature will drop. But maybe the temperature has dropped to 5 degrees Celsius from an earlier 8 degrees Celsius. Temperature has dropped to, let's say, 5 degrees Celsius. Now, what condition do you have? Because the ground surface has cooled down so rapidly, the air closer to the ground surface is having a temperature of 1 degree. Whereas at higher above, the air has cooled down, but not at the same rate because it was not in contact with the ground surface. So the air will have close to around 4 degree, 5 degree, 6 degree, 3 degree, anything but a higher temperature. So what does this represent? Here you have negative lapse rate. Even if the difference in temperature is by 0.5 degrees Celsius, that itself will be more than sufficient to initiate the condition where there will be no mixing of air at all. Right? So the air parcel will stay as it is. So here, as you can see, the cooling of the ground surface, the substantial amount of cooling of the ground surface has in fact led to the substantial cooling in the lower portion, but that has not translated above. So because the property of the ground surface is the determining factor here, that is why it is surface inversion. This is the inversion that we experience in the northern parts of the country during the winter months that exaggerates the problem of pollution that we face. Okay, so when we talk about surface inversion, it occurs when the atmosphere at the Earth's surface is colder than the layer above it. The above layer is warmer. Around sunset, the ground cools rapidly by radiating heat upwards into space. The air in contact with the ground cools by conduction, causing the lowest layer of air to be cooler than the higher layers. So, when will you observe this? Condition required. Conditions required. What will be the conditions required? Long winter nights, cloudless sky, or a clear sky. Why? Because when you have clouds up above on the atmosphere, let's suppose you have the presence of clouds. So what these clouds will do, these will basically, if the earth's surface is losing heat, the clouds will re-radiate that heat because it has water vapor present in it. So that is why they will not allow the ground surface to become so very cold so very quickly. So that is why the ground surface will continue to remain warmer. That is why you need a clear sky for the ground to lose heat considerably. So you experience it in northern part of the country during the winter, and this is the reason why during the winter, that is during these months, in all the northern parts, not only does the ground start becoming colder, and understand this phenomena, this is a kind of a feedback mechanism which gets initiated, which worsens itself. But understand the concept, it is very simple. So during the winter, what happens during these months? After Diwali and after the phase of stubble burning, there are a lot of pollutants which are laid up into the atmosphere, which are released into the atmosphere. But then you have during the night time the conditions of inversion because the ground surface has started becoming colder already. So whenever you have condition of inversions, the air will not mix together. The air will not mix ably well. So all those pollutants, they remain closer to the ground surface. They stick to the ground surface. Because of lack of mixing, you won't have any of those pollutants being dispersed anywhere. So they will stay where they are. So the if next day again, more pollution will be caused. So over a period of time, the amount of pollution keeps on increasing, adding a lot of dust particles, lot of smoke, lot of haze closer to the ground surface. Within 15 to 20 days, it starts blocking the solar rays. The solar rays, they don't fall with the same intensity that they fall in the otherwise cleaner air. For example, Delhi also experiences winter. Jammu Kashmir experiences a harsher winter. But observe the intensity of solar rays in Jammu Kashmir, they will be slightly greater. Why? Because the pollution is not there. So that is why when the solar rays start getting blocked, that means the land will get cooler and cooler. That means during the night, the temperature will drop further. Condition of inversion will be exaggerated. No mixing of air whatsoever will happen. That means wherever a particular air parcel is present, it will stay in that region only. And that basically worsens the health crisis. When will this abate or when will this go away? Either you remove the problem of pollution, which cannot be carried out due to political issues, etc. Problem of pollution is going to stay with us. And along with that, you also have to understand that when the heating of the planet starts to happen, then again, this problem simply goes away. Otherwise, it is this surface inversion happens during the night, disappears. Next day, when the sun shines, it disappears. But in northern part of the country, because you have so many pollutants, the impact persists. Okay, that is where we'll restrict here. We'll restrict the session here, and we continue again from this portion tomorrow as we meet. So surface inversion is basically, Sandeep, when the ground surface loses its temperature very rapidly, due to which the air closer to the surface also cools down, but the air above does not cool down at the same proportion. So you have a negative lapse rate created due to the surface phenomena, that is surface inversion. Okay. And Sarthak, in urban heat island, that evaporation of water in soil and trees are helpful in cooling urban area. But as we studied earlier, that water vapor is reason for greenhouse effect, in which the temperature increases. Um, increases present reason for temperature increase. That is true that when you have excess amount of humidity, there is a higher temperature. But in the urban landscape, always I say, compared to the surrounding areas, that water vapor eventually is also responsible for slight urban precipitation. Otherwise, the urban areas, they tend to remain drier. But the rate of cooling provided by this open tree or the open spaces or the shades is much higher as compared to whatever warming that water vapor will carry to do. Okay. And Gun or Gun, thank you, sir, for making geography so interesting. Started liking the subject. Journey of civil services is truly meaningful. So it is one of the good things that you have liked the subject. I hope this continues till the 24th module. Once you understand the concept of this subject, the moment you step outside your house, you will be able to relate to it. Very hard to forget. Pile. Yes, your question was that in winter season we found that groundwater is a little bit warmer, whereas in summer season, Pile, you will find that the groundwater is a little bit colder. The reason behind that is during the winter season, while the top surface manages to lose its heat and become very cold, that loss of heat is not managed by the water which is present underground. That is why it comparatively is warmer. Whereas during the summer season, while the top surface gains all the heat, becomes very hot, the groundwater is isolated from that. That is why during the summer you will always find that from the hand pumps, the water that you get is comparatively cooler. So it is that differentiation from the surface which brings about a variation in the heating and the cooling phenomena. Why warm air above doesn't mix with the cold air? Okay, you are saying that why warm air doesn't rise further up and mix with the cold air? Because sometimes it does rise up ever so slightly, but you have to understand it is mixing of the air closer to the ground surface, which is essential for abatement of any issue. Otherwise, even if the warm air above rises up furthermore, it will rise only up to the level of tropopause, not beyond that. Why does that happen? We'll talk about it tomorrow also. And Shazia, I'm almost confident in writing English, but when it comes to speaking, it is about communication, practice communication, it will improve. And Why surface becomes colder? Kuraku, during the night time, you will find that the surface will lose heat. It will become colder. During winter nights, doesn't the surface become cold? Why it becomes cold? Because whatever heat has been gained during the day will be lost during the night. Yes, Akhilesh, that is true. Does the soil which absorb more water or sunlight? Naveen, your question is not very clear, my dear friend. Moisture found in upper atmosphere, in high up in the atmosphere, almost negligible. In the lower portion, slight. Most of that water vapor moisture is restricted to the lowest portions of the atmosphere. Okay. Is this the reason why we experience colder at clear sky after it rain? Yes, that is true. In the lower portion of stratosphere, Ziba. Okay. Yes, Abhishek, you can. And last question. In the mountains region, we can experience sun burning, and at that time, we also experience much colder condition because in the mountains, the solar insolation is high, which will create. Understand, sunburn is never created due to temperature. It is never the case that high temperature will create sunburn. If that would have been the case, even sitting inside your house during the summer season in northern part of the country, everybody would have gotten sunburn. Why don't you get sunburn? It is exposure to that various wavelengths which initiates that reaction on the skin. So unless and until you are exposed to solar rays, you don't get sunburn. It is as simple or logic as it can get. But you have to understand that high up in the mountains, the intensity of solar rays is very high, but the retention of heat is very less. Why? Density of air is not there. The air particles are present in very scarce density, so there is no retention of heat. All the heat is almost lost, isn't it? That is why. Yes, Sandeep, more than sufficient. Which climate classification is superior? Trivartha is better, but you don't have to study it for GS. So that is where we'll restrict the session here for today. We meet again tomorrow, where we carry out the study of the permanent wind systems and the local winds as well. We'll understand those concepts. So that's all from my side today. Take care of yourself. Goodbye. Thank you.